Okay, let's start our session today. As it is already mentioned, the topics, the title of the topic, it is called relation analysis. It is a very common one topic actually. Many people who are, in fact, having some mathematics concepts, right? They already know this information, this topic, I think. Anyway, so this topic is a part of statistical learning strategies. So relation analysis, which is in the field of data analytics, it is a part of statistical learning. You know, nowadays it is a trend. Trend is artificial intelligence. The trend is machine learning. Trend is deep learning. So likewise, another trend it is also called statistical learning. So what exactly the concept of statistical learning and how it is possible? So that will be covered today one part and then tomorrow another part. So today is the basic part of the statistical learning, and then in our next session tomorrow, I'll cover the advanced part of the statistical learning. So let's start about what is the what are the concept of statistical learning. As I told you, so like machine learning, like deep learning, what we have to train a machine, right? So train a machine means we have to give some input to the machine so that machine can process this input. In particular, for example, if I give one value, say x, and then machine should return another value, it is called y, where x is dependent value and y is independent value. Now how this machine can transform an input to an output? So in between y and x we can assume one function, let the function be f, so y equals to fx, and here x can be a composite input. That means the x is a multi-dimensional data, you can think about it. Now here the function f. So the function f, how machine can think about, right? So we have to train the machine with some input about x, maybe 100 inputs, maybe 200 inputs, maybe 1000 inputs, and then the machine will learn from the given input and then decide about f, that is the function. So this function we can think about as a black box, right? So we just give an x as an input and it will return the black box, that is the machine will return you an output, that is the y. Now, so this is a very fundamental concept of machine learning, and statistical learning, like machine learning, it is also in fact a machine learning approach. So it will learn statistically. Now, what is the statistics or statistically? That is the idea actually. So there are certain statistical measurement which is very much important so far our data processing is concerned, our data is concerned. So it is statistics about the data. So if a machine can learn about the statistics of the data, then it is called statistical learning. Now there are two broad strategies. So far statistical learning is concerned, they are called non-parametric procedure. The non-parametric procedure when the data that is given to you as the whole population. On the other hand, the parametric procedure, it is possible only the entire population is not available to you, only a part of the population, a subset of the population is given. A subset of the population, it is called sample. So parametric based statistical learning is a sample based approach. On the other hand, the non-parametric procedure or non-parametric based statistical learning is based on population. So these are the two things. So today we will discuss about non-parametric procedure. That means given the whole population, then how we can learn something statistically. Now here obviously the two approaches, the first approach, that is non-parametric procedure, is applicable. It is applicable only when the population size is not so big. For example, say suppose we want to know about TRP, the television rating point light, right? So obviously the population, the all viewers, not only in our country India, because the viewers may be from America, maybe from Canada, maybe from Australia, like this, right? So for a channel, for a program, there may be huge viewers, and then it is impractical. It is not feasible to collect the information from all viewers and then thereby deciding the TRP. So in that case, we cannot think about a non-parametric procedure. That we can think about parametric procedure. On the other hand, non-parametric procedure, when very small size of data is available to you, which can be treated as a population, and then we can learn something from statistically. So today our topics limited to non-parametric approaches to statistical learning. Now, in this session, we'll try to, first we have to give a brief introduction about the concept, that non-parametric based approach, and then the topic can be refined further. Actually, we have to analyze something in so far the learning is concerned. It is called learning the relationship. What is the relationship? I gave you one example, like say X and Y. So there are two, values. We said that one is dependent value, another is independent value. So set of X and then set of Y. So we have to see whether there is any relation between X and Y value. So this relationship analysis, and then the relationship in fact a measurable quantity. That is very funny thing, but we can measure. So we'll see exactly how the relationship can be measured. Now, so far this measurement of relationship is concerned, there are many methods are known. They are discussed in the part of correlation analysis, like say Pearson correlation analysis, Spearman correlation analysis, chi-square correlation analysis, like this. So these methods, these are the procedure. These are the procedure by which the relationship between two value can be analyzed, can be measured. And there is another approach here, other than this correlation analysis, it is called the regression analysis. Regression analysis, in fact, the starting point of the machine learning. So we can say the first era of the machine learning, in fact, started with the statistical learning, by which we can regress. We can regress for a given set of values, what will be the output value like. So this regression again of different type depending on the type of regression, like simple linear regression, multiple linear regression, then non-linear regression, non-linear again simple, again multiple. So it's a very complex things are there, but learning only simple linear regression will be sufficient to learn others because they are just a bit extension of the simple linear regression method actually. And finally, in our session, we'll conclude our topics today, telling a bit about the auto-regression analysis. Auto-regression analysis is applicable to time series data, where time series data is very frequent in our data analytics approach. So these are the three topics that I'm going to cover to all of you. Let us first start with, so what we mean by relationship analysis. Now, I want to give an example so that you can understand the concept of relationship analysis. Then we'll see how this kind of relationship analysis can be done. So now let us consider that you have given a salary data for a particular region or a particular country, whatever it is there. Let us consider from the different companies, we collect the salaries that is provided by the employees and all the employees records are there. So it is the data that is given to you, which includes the salaries of a group of employees from a particular region in your country or in your state, whatever it is there. So this is your data, right? You can understand. So this data, it is not so big, not so large, it is a moderate size. Anyway, it is processable. Okay. Now, here we want to understand many information. We want to retrieve many information given this salary data. For example, we want to learn about the relationship between the employee's salary and then their ages. Okay, so whether we want to know whether salary vary with their ages, if it varies, then how it varies, whether increasing with their age or decreasing with their age or remain same. These kind of things are there. Okay, and second, another information, for example, from the same database, we want to find a relationship between the year and the salary. That means how salary varies with the time. So every year, whether salary is increasing or salary is decreasing or salary randomly changing or salary remains same, whatever it is there. Another, for example, say employees age and then education. How the two attributes, age and then their education levels are related. So whether salaries are anyway related with employee education level or it is not related, all those information. So given a data set, we have to find all these relationships among the different attributes. So this is called the relationship analysis. Now let us have a quick look about this is one example. So suppose the data that is given to you, you have a full liberty to plot them because it is a simple data. So salary versus, for example, age. We can plot, say, age is along x-axis, salary along y-axis. And here we see how the different salaries for the different ages can be plotted. So this is a typical view of the data points that we can plot on a two-dimensional graph. And it is called a scatter plot because it is just like scattering like. Now, so this is the data that is given to you. Now here the question arises. The question arises is that how salaries varies with ages. Now from there, can you conclude anything? Can you infer something? Now it is very difficult because it is so scattered, nothing can be planned properly. But if we apply relationship analysis, which right, then we may obtain particular portion of the graph which is shown here in a blue color line. Okay, so this is the one line which we can draw applying our data analytic activity, data analytic skill. Okay, now given a set of data, if we can draw that kind of line, then we can conclude many things about then how salary varies with ages. So we can say that yes, salary varies with ages, and then till 60 years of ages, salary usually increases, and after 60 years of ages, it is slowly decreases. So this kind of information that okay, layman can have from the given data, which was not possible from the raw data actually. So this is one typical example of a relationship analysis. So you can understand that okay how we can have the idea. Now the second example, for example, from the given data set, the data that is given how salary varies with the different years. So here I have plotted for 4 years data and then salary I have drawn that plotted it. So in 2010 how the salary varying. So there is a minimum salary, there is a maximum salary. In 2012 all these also right. So minimum maximum can be inferred easily, but we will be able to infer whether the salary varies with time. Apparently it appears that yeah, salary varying with time, but how it is varying. So this can be again applying if we follow relationship analysis activity. So the relationship analysis will give a trend and it is shown in the form of a blue color line. So this shows that okay, there is a slope and then positive slope. So positive slope implies that it is increasing with year, and from the slope also we can say what is the rate of increase. So all those information can be easily obtained provided that we can apply the relationship analysis and can obtain from the raw data something like it is shown here. And then another example, this is another example, say how salary varying with education level. Okay, salary varying with education level. So education level will be 10th standard, 12th standard, then UG, then PG, then higher PG, and all those things. And there we have plotted it. Okay, so all the salary having the 10th standard education level, how their salary varying, and so on. So this information it is giving there. Now here we want to learn about how salaries are related with education level. So can you conclude anything from here? Possibly you will not be able to conclude so confidently. Then what is the way out? The way out is that again data analytics or data science we can apply. Now, so this is another relationship analysis that we can apply on this raw data, and then we can, this is called a box plot. Box plot is one method by which we can plot something, and box plot give a information about a series of data regarding mean, median, mode, and Q1, Q3, and then max. So this is the result that you can get it. And from this box plot, we can have certain idea about that the maybe say median. Median is increasing slowly because the middle that's a bar. It is actually the median, and so you can connect all the median. Then you can say that yes, median is. So what you can say that on the average salary increases with the level of education level. And how it is increasing? It is not increasing as much as it is shown in the figure. It is increasing slowly, whatever it is here. So this is the scenarios where the relationship analysis is highly applicable. And there is a procedure by which we shall be able to obtain all those information. It is like this here. Now let's come to the solving the problem. Our objective is to see what is the procedure by which we can learn about how the relationship among the different attributes are there. Now it is an example, and this example we can consider as a challenge that you can take, so that if you can solve it, it is very nice. The problem here, you can understand this is a very, again, like a scatter plot data. Maybe say 50 points are there, and then 50 points are specified by one x value and y value. So this is just simply a xy plot, you can say, right? So there are 50 points. Now the problem here, I just pose a problem like, so can you represent all 50 points using only 1 point information? For example, here to store 1 point, you need x value and y value. X is a maybe integer or a floating point value, y is another floating point value. So 50, one floating point value, maybe say 4 bytes. So 4 bytes for x, 4 bytes for y, that is 8 bytes for 1 point, and 50 data are there, 50 into 8, so 400 bytes are there. What is my question is whether we can store the same information only using 8 bytes, not 400 bytes. Now suppose instead of 50 points, given you 500 points, I again repeat the same question. Can we represent all 500 points by only 1 point information, maybe 8 bytes information? And like this one. So whether it is a 50 or 500 or 5,000 or 5 lakhs, whatever it is there, our objective is to store the information only using 1 byte information or 8 byte information. Now it is really a challenging problem, but it is not exactly a challenging problem. It can be done very easily. What is the idea? Idea is if we can interpolate. What is the idea of the interpolation? You see, I draw a line passing through all the points, but there are infinite number of lines are possible, but we have to select that line which is in fact closest to all the points, or all points are closest to this line. Now here is again problem how we can do, but it is there is an algorithm by which we can do, of course. So what we want to do, so draw a line in such a way that all points are very close to that line. If a line is possible, then that equation of the line we can represent y equals to ax plus b. Now you see, to store the information of any point, we can tell that what is the x value, it will give you the y value because they are related with the equation y equals to x plus b. So it gives a relation. It gives a relation between x and y. So given a value of x, what is the value of y? So this gives a relation. And to store this relation, only 2 parameters are required. The parameters are, for example, a and b. If another data point is given, then definitely it will give you another straight line, and then another values of a and b. So it depends on, okay. So a and b, the 2 point information look like. So only we have to store the values of a and values of b, like values of x and values of y. So instead of storing 50 or 500 or 5,000, only we have to store the values of a and b. This gives a relationship between x and y, and by which any point can be represented. So this is the idea, right? So here the idea is that we have to find a model. Actually here y equals to x plus b gives a model. The model represents every point. This means this model just like a black box in your machine learning. So if you give an input x, it will give an output y. So this is the concept that it works here. So with this we can start that, okay, therefore we can measure the relationship, or we can represent the different attributes in the form of a relationship or in the form of a model. Now, so far this model building is concerned, what is the input? The input is required set the points, whether 50 point or 500 point or 5,000 point, whatever it is there. So this is the input that is required so that we can build a model. Now this input we usually call population. Again, there are different type of population. The first is univariate population. Univariate population means only set of numbers given to you or set of string given to you. For example, here a set of temperature maybe for 1 week. So this is a univariate population. That means it is only one variable are there. So only the temperature. Now bivariate population, for example, you want to store pressure versus temperature for again say maybe 365 days or maybe 54 weeks, whatever you can say. So here is the result. For example, if pressure is 1 for 1 day, then the temperature is 35 that day, 1.1, 41, and so on, so on. So here we are storing the two values, or you can say two attributes values, or two variables, and that kind of population is called the bivariate population. So bivariate population has two rows, one rows corresponding to one attributes, another rows corresponding to another attribute, or we can say if we vertically draw this table also column wise, so two columns, pressure and temperature. It is just like a simple table with two columns only, that also we can tell about. So this is a bivariate population. And other than univariate and bivariate population, there is another type of population is called the multivariate population. As the name multivariate implies that it is more than two variables are involved. For example, if you want to store the data regarding pressure, volume, temperature, or pressure, volume, temperature, humidity, or pressure, volume, temperature, humidity, and viscosity, and so many information that we can, right? So it is multiple variables are involved, multiple attributes are involved, then it is called the multivariate population. Now the relations analysis that we are wanted to do for a single variate population, the relationship does not give any meaning, so it does not have any significance also. But bivariate population as well as multivariate population, this relationship analysis important, right? So relationship analysis, if we say, it implies that it is applicable to bivariate as well as multivariate population. Now, the idea that we can apply to bivariate population also can be applied to multivariate population. I will mainly focus on bivariate population, and the same way the multivariate population can be applied to that, for which I will give an hint. Now, here see how we can measure the relationship. So our objective is to find the relationship, if any, and then measure the strength of relationship. Now, so this measure of strength of relationship is also in other ways called the association between two or more variable. Two variable means bivariate and more variable means multivariates. And if there is a relationship also called association, or more precisely in the field of statistical learning or data science, it is called the correlation. So we have to check first whether there is any relationship exist or not. Relationship means correlation, right? And if any relationship exists, then we have to find the measure of relationship. That measure of relationship, it is called degree, right? So these are two questions. One is that given a bivariate population, simply population, right? And then you have to find whether there is any association between the different variables involved. And second is that if there is any association or correlation exists, then what is the degree of the correlation? Now, whenever degree is concerned, then degree has two important concepts. It is the value as well as the direction. Now, we will start about what is the value of the direction shortly. Now, to find whether there is any relationship exists and then degree, there are two broad approaches. One is called the correlation analysis and another is called regression analysis. So first we will start our discussion with correlation analysis, and once we learn the correlation analysis, then we shall do the regression analysis. Correlation analysis is in fact easy to learn. Now let us start about the correlation analysis. Again, we will consider about bivariate population for simplicity in discussion. Okay. So for example, here two attributes A and B. A attributes has a set of values, it is called the range of values. Similarly, B attributes has a set of values, it is called the range of values. So what is the input that is given you? You have given a table consisting of set of values related to A and set of values related to B. And what is our objective? We have to find the relationship between A and B. That means if A and B, they are associated, or there is any correlation between A and B, and then degree of. Now this correlation can be termed as a positive or negative or zero correlation. Positive correlation means If the values of A increases with the values of B and vice versa, then we can say positive correlation. On the other hand, it is negative correlation if the value of A decreases with the increase of the values of B or vice versa. Then it is called the negative correlation. And if the values of A and the values of B, there is no increase and decrease, like they are random in nature, then it is called the zero correlation. So the correlation can be of three types: positive, negative, and zero. So this kind of type, the positive or negative, is called the degree of direction of correlation. And then if the correlation is there, what is the strength of the correlation? Now let us start with an example, very simple example. Here the two attributes, one is our study and exam score is given. It is very simple to understand. So there are 10 students, for example, and for 10 students we have collected the data that how much hours they have studied a day, and then what is the exam score that the students secured. So this is the information, and using our simple plot, that hour of study versus the score, if we plot it, then we can get some points which is shown here in a black dots, and then drawing a line passing through all the points, it looks like. So then you can understand that, okay, whether it is a positive correlation or negative correlation or there is no correlation, you will tell that, yeah, there is a correlation, because here the exam score increases as the hour of study increases. So this is an example of a positive correlation. So correlation exists. Correlation exists between our study and exam score. Now, correlation exists. Correlation analysis is applicable to some meaningful scenarios. For example, number of CDs sold is another attribute, and number of cigarettes sold is another attribute, and some values obtained there. So apparently, we can see if we plot the points, that means number of CDs sold along y-axis, number of cigarettes sold along x-axis, and then the points are there. And if we plot, then we can get some curve look like, that's the interpolating curve, right? And then we can say that, yeah, there is a correlation, positive correlation. But actually, if you see this x and y, the number of CDs sold and number of cigarettes sold may not be any way related, because they are two independent events. So if the two events are both independent to each other, although they are seemingly any correlation exists, but it is not a meaningful correlation. So what I want to say that correlation valids if the two attributes are meaningful. Now here is a few example again. You can understand about, as I said, there are three different type of correlation. Positive correlation, how it looks like. I didn't plot any line in passing through all the points, but you can easily draw a line, then you can understand. So positive correlation means a straight line like which has the positive slope. A negative correlation like a straight line which has the negative slope. And zero correlation, you cannot draw any lines because the points are random. So it is a zero correlation. So from the graph itself, we can have little bit idea about whether the correlation, the positive or negative, and then or zero correlation, we can have certain idea. But the measurement of the correlation, the strength of the correlation, or it is called the degree of correlation, or the degree of relationship, it is not possible from this kind of graph. So we need something else. Anyway, so in data science, the correlation degree of association or degree of relationship or measure of relationship is expressed by a symbol. It is called the R. This R is called correlation coefficient. The values of R always lying in between +1 and -1, both inclusive. So the maximum value of R is 1, and then lowest value of R is -1, and in between obviously zero values are there. So if R is positive, then we can say there is a relation, it's called the positive correlation. If R, the values of R is negative, then we can say negative correlation. If R equals to 0, then we can say we don't have any correlation. So from the values of R, we can understand about whether positive, whether negative, or no correlation. Furthermore, if the values of R is 0.9 and the values of R is say 0.5, then we can say that which one has the highest correlation. 0.9 obviously very close to the maximum value than the 0.5. So we can say 0.9, the data having the correlation, the coefficient 0.9 is much more correlated than the data having 0.5. So from the values of R, we can therefore tell about the strength of the relationship. So R, therefore, if we can calculate the values of R, it will tell you many information, whether the correlation exists or not, whether the positive or negative or no correlation, and then what is the degree of correlation. All the information is here. Now let's see, given a set of data, how we can find these values of R, because it is our ultimate target, so that we can measure the relationship. Okay. Now here is a few example. This is the first plot, the left and then topmost plot is a high positive correlation, and the second is low positive correlation. You can understand the between the two, right? In the right side is a low positive correlation, and the left side is a high positive correlation. When high positive correlation, if we draw a line, all the points are very close to the line, right? If low positive correlation means that we will not be able to draw any line, or even if you draw the line, then all points those are to be passed through that line is not so close to each other. Similarly, negative high correlation, only the inclination or the slope will be different, otherwise the same thing, like say low negative correlation. Now, so this is the values of R equals to +1 or R equals to -1, and here I want to mention one thing is that if the straight lines we can draw passing through a set of points, and then if the line is possible, and then it is called the positively correlated, and if all points lie on the line, then we can say that R has the highest value, that is a +1. But it does not include about what is the slope. Whatever be the slope, that is not an important thing. Only point that if all points are lies on the line or not. Now this again, the points may be lie not a straight line, but it is a curve. For example, in the last figure B, we can see here. So here we can see all points are lie on the curved line, right? But it is again strong correlation, positive correlation. In this case also, of the values of R equals to 1. And where it is the positive slope, R equals to +1, when the negative slope, R equals to -1. And when the random points are given, there is no line drawn possible, so R equals to 0. So this concept it is here. Now, in order to measure the degree of correlation or correlation analysis, there are three important, very popular, although these are the method known in the field of statistics for a long time, maybe 100 years old, but still it is equally applicable. If they are so strong, then the very popular method. The first is Kharagpur correlation analysis method. This method is applicable to find the correlation analysis between numerical attributes. That means data A and B, for example, two attributes are given which has the range of values only numbers. Charles-Spearman correlation coefficient, on the other hand, if the attributes that is given there in the data set, they are ordinal attributes. Ordinal attributes means sort of the size. So smaller, medium, large, XL, XXL, these are the called ordinal values. Okay, ordinal values. And then categorical, say gender may be male and female, they are called categorical attributes. The chi-square coefficient correlations analysis is applicable to categorical attributes. So I have listed three methods, because I have listed three methods in such a way that all type of data can be processed, can be analyzed. That is why. So Karl Pearson, numerical attributes, Charles Spearman, ordinal attributes, and then chi-square for categorical attributes. Now Charles Spearman coefficient also alternatively called the rank correlation coefficient. It is the idea of it. Now let's start with first Karl Pearson correlation coefficient analysis. Here we assume that two attributes are given to you. You can say X is the one column, Y is the one column. So X has some set of values, Y is also another set of values. So they are given you. Okay, so this is your table. This is your population data, we can tell. Now we can calculate the Karl Pearson coefficient, which is usually denoted by R star, or to make it more distinguishable from other correlation coefficient values. So it is called R star. R star is denoted as summation of xi minus x bar into yi minus y bar, where x bar and y bar, they are called the mean of the population. And xi is the ith data in the population. Yi is also another ith data for the population corresponding attribute y. And sigma x and sigma y, they are called standard deviation for the attribute x and standard deviation for the attribute y. Now at this moment, I assume that all of you are aware about how to calculate the mean. Mean is very simple. For a given set of numerical values, we can calculate the average. So mean is nothing but is arithmetic mean actually. So the average. and sigma x is a standard deviation that possibly you know. So that if a set of values are there, and then the standard deviation is xi minus x bar whole square for summation of all the values of I divided by 1 by n minus 1. This is the formula. Okay. So standard deviation for any set of values, average for any set of values can be calculated. So sigma x and sigma y denote the standard deviation for set of values which are there in attribute x, and then sigma y attributes y. Now let us take an example so that we can understand this concept very clearly. So this is the formula proposed by Karl Pearson, and it is called the Karl Pearson correlation analysis. Now here is an example. As you see, we have considered 17 records, the data. So the size of the population is 17 in this case. What is the data? The first attributes is a gestational age. So is the amount of weeks that the baby was in his or her mother's womb. Okay, so this is the gestational age. And then the next attribute is called the birth weight in grams. So that means at the time of the birth of the baby, what was the weight of the baby. So we have collected the two set of information, gestational age and the birth weight of baby for 17
Thank you very much.
Babies.
So,
okay? And then we want to find whether there is any correlation between gestational age and birth weight.
Start, there is a short disclaimer that I want to put forward. So this presentation may contain some offensive words. However, this cannot be avoided, because of the nature of the work that we have been doing. But we have tried to suitably obfuscate them whenever it's appropriate.
Without any calculation, guessing an idea may not be so much wise idea.
Social media these days needs no introduction.
If we apply the Pearson correlation analysis to this data,
default go-to for any sort of information seeking. Actually, people rate social media as one of the prime sources of their day-to-day news.
Data that you can see.
Again, these days, therefore, I don't ask students are you a part of social media? Rather, I ask how many social media are you part of? So basically, that kind of defines our social dimension. Like some are part of only one social media, some are part of,
and it shows that 38.4.
Like
and then what is the average weight of the baby? So it shows that 2.9 kg.
So frequently.
And then what is the standard deviation for the x attributes? It is 10. And what is the standard deviation for the y attribute? It is these values. And then we can calculate R star. The values of R star that can be obtained from the data is 0.82.
Social media has,
so the value of R star is positive. So we can say that there is a correlation
various
and
positive
correlation. And this R star is very close to 1. So we can say
various
it is
interesting
strong
topics. You can get connected to people very quickly. You can make friends. You can unfold business. And then there are lots and lots of positive sides of social media. However, like any other
the degrees of
invention, right?
So this is the idea about
the atom bomb, or be it the internet, or be it social media, there are always some negative consequences. And today in this talk, I'm going to summarize a little bit on some of these negative consequences. One is like increased polarization. So with the advent of social media and the increased use
because of human error, data entry error, or whatever it is, they are called the outlier. And it will influence
polarization
the calculation of R
we
star
are seeing in
significantly.
terms of
Now we have to check
different
whether this
sensitive
R star
attributes
calculation
like
is significant.
ethnic
That means there is no error,
groups,
and whatever the value of R that we have calculated,
minority,
it is significantly
and all these
correct.
type of things. And there are polarizations around them.
This is called the
There is a lot of abuse, and
we have to calculate a t-value calculation
typical form of abuse, which we call hate speech, is actually inflicting the social media like anything. And this is like an ever-increasing problem now.
And then t-value can be calculated. For example, for the given
even
data,
the governments, the social media companies, they themselves are pretty concerned about some of the issues and some of the challenges that this kind of hate speech actually produces.
This table tells about
seems like
the different degrees
it's
of
not
freedom,
only like
and for a given level of
restricted within
confidence,
the
what is the value of P
online
that we
world,
can consider?
but it
If
has
the value of P
now
above this, then we can say that
permeated
they
to
are
the offline
rejectable,
world,
otherwise
and
they are
there are
acceptable
many
or significant. Now say
unfortunate
level of confidence say
offline
0.1,
consequences.
1%,
We will
you
see
can
a
say.
few
So
examples here.
0.1% is
So, for instance, the
0.001, we
Bulandshahr
can
the
say this is the
Pittsburgh
level of
shooting,
significance. And then
some
we'll
of them
discuss
at
the
least,
level of
the
significance when
Christchurch
we
shooting, the
discuss
Rohingya
much more
genocide,
about the
the
advanced
Sri Lanka
concept
riots.
tomorrow.
Many of
Anyway,
them
so this is
had
one
a
significant level. That means how
precursor
confident you
in
are
the
about the
social
result.
media
And
platform.
degree of
So
freedom,
the
actually,
violence
it is the
kind of
measure.
started in the social
If the
media
n
platform
data
long
is
back,
there,
and then
simple
slowly
univariate data,
it
then degree of freedom
permeated
is called n
into the
minus 1. Now, and
offline
if it is
real
a
world,
two-column data, then
and
degree of
caused a
freedom is called n
lot of
minus 2. So in this case, n is 17, so
like
degree of
loss
freedom
of
is 50.
property,
So
loss of
in the
lives. For
t-statistical
instance,
table,
I guess
for
many of
different
you
values of
have
alpha
read
and for
many
the
reports,
different
news
degrees of
reports
freedom, we
related
can
to
obtain the
the
values of
Rohingya
t value.
genocide at least. So this is one of
So
the
t,
closest
for example, for the
things
on the
that
statistical
have
table with
happened
alpha is
to one of our nearby
0.001 and
neighboring
degrees of freedom
countries,
15, it shows that t
and
value is
like people have
5.72.
been
Now, if
constantly
the t value that
seeing
you
evidences
calculated
that
from your data
Facebook has been
is made
playing an
better
active
than
role
this statistical t value,
in
then we can say that
like
this is not valid, this is wrong information.
igniting this
And if your p
fire
value
of
is less than this
violence
the statistical t value,
against the
then you can
Rohingyas.
say that okay,
So
whatever the value
similarly,
that
for
you
the
obtained, it is
Pittsburgh
valid
shooting,
up to
we
this
will
level of
see
confidence.
like there
So
was
in this
another
case, t value
such
that we have
social media
calculated from our
platform
population data
which
is
was responsible,
1.44, and the
this
statistical value it shows that t equals to 5.72. So you can see that
has
it is
been in
acceptable.
its
So the calculation is acceptable, or
infancy
it passed the
in the
significant
platform
test.
for a long
So we can
time,
say that
and then finally it
the result
materialized
that we
into the
obtained, it is
offline
not
world.
by chance, rather it is
So
proper
and
values
it
due to the
seems like
proper value,
none
and
of the
then we
well-known
can be
social media
consider that
platforms are
they are highly correlated and highly significant.
free from this
So
kind
this
of
is
hate
about
speech.
the Carl Pearson
Each and
correlation
every one
coefficient that we
that
can
you can name
try.
of
So now
actually
let us
is
consider
kind
about
of
another
inflicted with some or
correlation
the other
analysis.
form of
It is called the
hate speech. For instance, this is
Spearman
one
correlation
example
coefficient
taken
analysis.
from Twitter.
Now,
This is
as I
another
say,
example
this
taken
type
from
of
WhatsApp.
analysis
This
is
is a WhatsApp
applicable
group
to
in
ordinal data, whereas Carl Pearson
India.
correlation analysis
Okay,
is
this is one of the
applicable
public
to
groups in
numerical data.
WhatsApp
Now,
in India,
ordinal
and
data, as
many
I
of
say,
you,
for example, height
I
and
guess,
then
are
PISA.
able to
We
already
can represent the height
read
of a
and
person as if he is
appreciate
very
that there is a lot of
small,
hate content in this
right?
message.
Low, taller, very
And as I
taller,
was
it
telling
kind of
you,
that,
so there
right?
is this
And then
another
these
social
are
media
also according
platform
to with
called
ordinal data,
Gab.
we can represent
Okay, this is
XS,
gab.com,
S, L,
and I guess
XL,
some of you have
XXL.
already heard
Possibly you
about
can
the name
understand
of
what is the
Robert
meaning.
Boers,
Now
who
they are
was the
ordinal
prime
because
convict
ordering is
in the
applicable.
killings
So
or
if you
in
see
the
the very small
Pittsburgh
and then
shooting.
very
Okay,
tall,
and this
then
was
you
his
can understand
last
that
post
how they
that
are
he did
in
on the
order. So very small in the order,
and
maybe it is in a
did the
lower side,
shooting.
very tall,
So,
higher
and you
side.
see what he
Similarly, S
says.
and XL, we can understand how they
Here are
are
slides to
related.
bring
That means their
invaders
ordering can be
in that kill
implied
our
from the
people. I
level
can't
itself.
sit
So
by
this
and watch
concept,
my
that is why
people
they are called ordinal
get
data.
slaughtered. Screw your
Now, what is
optics.
the first idea about this
I
Charles
am going
Spearman
in.
correlation
And just
coefficient
after this,
is
he went
that
on
is why
and
it is
did the
also
shooting.
alternatively called
In
rank
fact,
correlation.
for this
Given
particular
a set of
reason, the Gap
attributes, whatever the
website
two
was
attributes or
closed
more
down.
than attributes,
All their
whatever it is there, let
servers
us
were
consider
closed
two
down for
attributes,
the next
and all
1 week,
attributes are defined with
actually,
ordinal values.
so
Then
that the
first we have to
aftermath could be,
apply to the
handled in a better way.
rank to them. That means
So
all ordinal attributes can be
we tried
assigned
to
certain rank. For
look into
example,
some of the
they are very
aspects of
small
this
can be
growing
assigned rank 1,
problem in
then
social
small is
media,
2,
and
large is
so far
3,
our
tall is
efforts
4,
have
very
been in
tall is
studying
5.
the spread
Similarly,
of hate
XXL
speech,
can be some rank values
temporal
can be assigned.
dynamics of hate
So
speech,
rank values
detection of
actually
hate
tell
speech,
about
misogyny
how
detection,
if
that
it
is
is a
like
number, then
hate
in
speech against
ascending or
women
descending
in
order, how we can
specific,
track.
and
So there is obviously
like
certain
ways
procedure
to
by which
combat or
rank can
fight
be
hate speech in
calculated
social
for
media.
each values.
That is what
Now
we call
again, what I
countering
want
hate
to say,
speech.
this is
So
important that you should know.
presently the
The
team
rank can be
comprises myself
calculated
and
for
another
the
faculty
numerical
member,
data as
Professor
well.
Pavan Goel,
This
from
means
the same
that this
department,
Charles
and 3
Spearman
PhD
correlation
students,
coefficient,
Bini,
although
Purnojoy,
it
and
is
Mithun.
initially
So
planned for ordinal data, but can be applied
problems
to
relating to this area,
numerical data as well
and
as.
I'll be
So
talking
this is a
about
great
2
advantage of
specific
course.
problems
So
today.
it can take care both
So
ordinal
the
data as well as
first work that I'm
numerical
going to
data.
talk about
Now
is
let
the
us
spread of
consider how we can,
hate speech
what is
in
the Charles
online
Spearman
social
correlation
media. So this
coefficient
was
is.
published in ACM
So
Web Science
likewise the
in 2019, and this paper also received the Best Paper Honorable
We
Mention
also
in the
can
conference.
express one formula
So
for
this is
calculating the RS.
about
RS means it is Spearman
a
coefficient.
specific
This
platform
formula
of
is
which I
typically
already
look
talked
like 1
about. It's
minus
called GAB.
6 sigma
and GAB is
of the
already
AC summation called DI
known
square
for
divided by N into N
its
square minus
loose
1.
moderation
By N is the
technique.
total number
So
of population, right?
it
It
has
is the
been
size of the population. And DI is the
said
difference between the
that
rank for the
GAB
ith
actually
pair.
champions
As we
free
are considering
speech,
the bivariate
but many a
population, so
times
pair of
many
values are
news
given.
reporters
So DI
have
actually
criticized
it tells
GAB
about
to be an echo
difference
chamber of
between rank of the
alt-right
pair of two
users.
variables.
Alt-right
We can clear
means
this
far
idea
right
if we can
people.
take an example.
And
And
similar
here is an
to
example
Twitter,
that you can think about.
in terms of
Say this
posting
is again another
content,
set of data. This data
you
is
can
collected from the
post
geographical
a message, you can
perspective.
repost a
So
message,
here we
users
can
can
take
follow
the
each
different
other, users can
statistics of the
like
different
a
rivers.
message,
So it
users
is
can reply
wide
to a
and then
message.
depth, right?
The
So
platform is
the
very similar
different
in
rivers
spirit to
and then widths
Twitter.
of the different rivers
However,
and then depth of the different rivers are collected and they
free
are
speech
connected and then stored in the
and
common
in the
lattice strip. So
disguise
width
of
is
this,
in meter
it
and depth is
actually
meter. These are the
allows
two numerical data, for
users
example.
to
I am not considering
post
about the
hateful content
categorical data
without
anyway, so it
the
is not
fear
the
of
big job.
repercussion.
Now here
So
our
GAB does not take strict measures like
test, that means we want to learn
say
about,
Facebook
we
and
want to learn
Twitter,
about that
who
whether the
these days
depth
have
of a
started
river,
taking very
depth of a
strict
river
measures against
progressively increasing
post of
with the
hateful
width or
content
not.
on the platform.
Okay,
So
so it is
either
the
they
concept, right?
delete the post
So
immediately
according to the
or
Charles
they
Spearman
suspend the user.
coefficient
They could
correlation
be as
analysis, it
harsh as
assumed
suspending the user
a
account
hypothesis,
directly.
like have to use for the
However,
null
GAB has
hypothesis. It
this
says
loose
that no,
moderation.
the data that
It
is
says
given
that
to you,
it
it
wants
does
to
not have
promote
any
free
correlation. So
speech,
that is why.
and
Now
therefore
we
it
have
does
to
not
either
deter
accept
the
this.
post of
That
any
means if you
hateful
accept this,
content,
then we can
and
say that no
therefore the
correlation.
users here
If you reject this, then
actually
you can
can
say no correlation is there and this is the
post
correlation,
as much
positive or
hateful
negative. You
content as
understand?
possible
So this is
without
the
any fear of
analysis
repercussion.
method, Charles Spearman analysis. It
So
takes the problem
one
as a
good thing about
hypothesis,
GAB is
or
that
more precisely
it
it is
has
called
an
the null
API
hypothesis.
by
That means
means
there
of
is no
which
correlation.
we were able to
Okay, but we have to
crawl
either prove
around
it or
21
disprove it.
million
That is our
posts and
objective. Okay, so we can apply the
343,000
Spearman
users
correlation
from
analysis.
GAB.
Now to do these
So
things,
this
as
is
I
the
said,
almost the
that we have to
total
calculate
volume
the rank
of
as the data it is given to you is
GAB.
a numerical
We
value.
were
If it
able
is the
to
ordinal value also given, then
crawl
also
them,
we have to calculate
and
the
as I
rank.
said,
Then we assign the
it
rank for
has some
all
very
values.
basic
So
information
let's see
like
how
the
the rank can be
user
calculated.
details,
There
like
is a
the
procedure, very
names of the
small program you
user,
can write.
the people
And
whom the
first
user
the
follows, and so
idea
on and
is
so forth, and
the
also all the
highest value that
posts
is
and
given to
reposts
you, the
from the
largest
user.
value that is given to you, assign it with the
And in
rank
this
1.
particular
Then the
task,
highest value
we
always
try
top,
to
that is
ask
rank
this
1.
question
Then
that
next
if
highest
you really
rank 2,
allow
and the next
hate
highest
speech
rank
to
3, and
spread
so on
in
so
the
on.
network
But in the
without
series of
any
data that is given to you, maybe 2 or
intervention,
more data
then
have the same values, then
how
how we can assign
fast
the rank?
does it
So it
spread?
takes that,
Does
okay,
it
you
spread
just go
as
on
fast
assigning the rank
as
in the
any
increasing
other
order,
message,
and
or
then
does
take,
it spread
if they
faster,
are of
or
same
does it
values,
spread
then take
slower?
the mean of
So
that.
given
For
the
example,
GAP
here you can see
network,
for
GAP
30
social
rank 1,
network,
for
and given
25 we
that there
can
is a
give the
hateful
rank 2
message,
because this is the
will
next
spread
highest.
faster
Then another
than
25,
any
another
other
25. So we can
XYZ
give the
message
rank
which is
2, 3, 4,
non-hateful,
and taking the
or
mean
will it
of the
spread
ranks
slower,
that is assigned to all equal
than
values. So you can say 3. So we can
any
assign
other
all this
message.
set of values. The rank 30 is 1,
So for this
25 is 3,
experiment, what
and
we did
20
is
as 5.
we
So this way you can
created
assign the
a
rank. You
small
understand?
seed
So
set
okay, so
of
rank assignment is
hateful
possible like
users
here. Now for the
who
given data set
each of
that we have
whom have
already mentioned
done
here,
at
this
least
see
10 or
how we
more
can
hate
assign the rank
posts.
to each.
So
So this is the one
set.
contingency
Now
table that
from
we can
there,
follow.
we created
So
a repost
in this
network
table,
of
so this
users,
is the
and
first
then
input
from
data
there
that
a
is given here,
corresponding
and we
belief
have assigned
network.
the rank to here.
I will
So
come to
highest
the
value is
description of
500, so
each of
rank
these
1,
in the
next
later
is
slides.
lowest is
So now
480,
we
and this way we
initialize the
apply the
seed
rank.
set of
Similarly,
hateful
another
users, the
attribute,
ones
this one
that
is
we
the
have
another
chosen as the
attribute,
seed set.
and we have
We
assigned the
tell
rank. So
that
these are the
all of
assigned
these
rank for
users
all
have
these
a
values.
score
So 1 is the
1,
highest,
while the
then
rest
next,
of the
and so on.
users have a score
So
0.
rank have been
Then
assigned.
we run a
Then
very
once the
simple
rank has been
diffusion
assigned,
model.
we can
We will
calculate the
describe
DI
this
value,
diffusion
because in
model
the
also in
calculation
details.
for the Spearman
To
coefficient, DI
update the
value is
beliefs
required.
of the users,
So for this, the
and
DI is
then
0. For this, the rank is
finally
9.
we
Here
get
rank is
some
9, so DI
users
is 0.
who
And
have a
so
belief score
here
between
0, but here you
0.75
see
and
rank is
1.
-1,
We call
and
these
here also
users
rank is
as
1. So
hateful,
this way,
and we denote them
DI,
by
these
the
are the
acronym
difference
KH.
between the rank
and
of
the
the
rest
pair
of
of
the
values. We can
users
obtain.
who are
Okay,
in the
they
range
are
0 to
right in
0.5
their
scores.
very
We call them
orthogonal type. Their values
non-hateful
will be very
users.
less. Their difference of the rank will be very high.
And these are
Otherwise,
around
if there is
58,000 in number.
0 and
So
whatever
you
it is
see
here.
that
So
we have
it is any
left a
value,
big spectrum
positive, negative,
of
maybe. This is the
users
DI values
from
that we can obtain. And
something
then that
smaller
it
than
requires the summation
0.75
of all
to
DI
something
square
larger
values. So
than
DI square it is
0.25.
here,
This
and all
is a
summation it
spectrum
will
on
give
which
you
we
4.
don't comment. We only take the
So we
extreme
got
zones.
this from the given table, like this one, we calculate this one. So 6 into 4
the zone
divided n is 10
of
here. So 10
0.75 to
into
1 score
99. This is the result.
actually
It will give
defines
you
our
RS equals to
hateful users,
0.9757.
and the
Okay.
zones
So this is the significant coefficient, that is the
users
degree
having
of
a score
correlation
from
coefficient we got.
0 to
Now from this
0.25
value you can interpret
indicates
what
the
is this.
non-hateful user. So now
It can be
the first
interpreted
question
that
is how to define
yes,
this seed
the
set
value of
of
RS
hateful
is
users.
very
So what we did,
very
we
close to
prepared
+1. This
a
means that it is
lexicon
highly
of around
correlated, and
45
then
very
positive
high
correlation.
precision keywords,
Again, the
okay, which are
significant test
representative
which
of
we have
hate, which are
applied, like the
indicative of
Carl
hate.
Pearson
For
also, we can
instance,
apply
words
here
like
to check that whether
KIK,
this significance,
words like beach trail,
this
words
result
like
is
Paki,
significantly
these are
valid or
all
not. Again, we
racial
use that.
slurs.
There are many
Okay,
other methods
so
also. For example,
KIK and
there
Paki
is a
are
Spearman
racial
chart is
slurs
available
against
for
Jews
the
and
different
Muslims.
significance
Beach
level
trail
or
is a
acceptance level.
slur
Also, we can
against
say 5%, 1%, then
we
0.1%,
make a
and this is the
set of
graph.
such
And then
45
degree of
high
freedom
precision
actually here,
keywords,
as I
okay,
said,
which are
total number of
indicative
record
of
10, so
different
degree of
types
freedom
of
is 8.
hateful,
So for 8 degrees of
which
freedom,
have a
and say
hateful
if the
semantics
0.1%
embedded in
level of
them.
confidence,
And in
we
GAP,
see this
if
value
somebody is
is
using
above
these kind of hateful
0.997.
words, then
So
you are
as this
pretty
value
sure
is above
that this guy is
0.997, we
actually
can say that
posting
because
some
above
hateful
means it
content,
is
because
rejected.
GAP has
So
a
this
very
means
loose
we
moderation. So
initially,
if
the
it was
Spearman
like
initially assumed
Twitter
that there
or
are no
Facebook, we would
correlation,
have to
but
take
it
this with a
reject
pinch
this.
of
That
salt,
means there is a
because there the
significant mission, and then
moderation is more
significant
strict.
also this one.
However, here since the
And this
moderation is
significant
very
level,
very
as
loose,
it is narrower,
therefore
then it is more stricter. That means we
you
are
can
more confident that our
like
result is more
almost
confident. We
surely
can say that
assume
yes,
that
they are
these words,
strictly
if they are
significant. They
present
are
in any
strongly
of the posts,
related.
then
This one.
they
So
would
this
be
is the
indicative
significant
of a
test.
hateful post. And we
Alternatively, the
find out
significant test that we
all
have applied to the
users
Carl
who have 10 plus
Pearson
such
also, we can apply
posts,
it
okay,
here. So this is
having
the
one or
idea
more
about
of these keywords.
the two methods
And
that we
these
have learned
users
about.
form
One is the
our
Carl Pearson,
seed
another
set of
is
hateful users.
Spearman correlation analysis. There is one another correlation analysis.
Okay.
It is called the
So
chi-square correlation
we
analysis.
construct the
It is also
repost network.
it is proposed
So
by
let
Carl
us
Pearson
take
again.
this
So
very
in many
simple
books, it
example
is also termed as Pearson's
and
chi-square test. And
the
it is called
repost
chi-square
network.
because it
Let's say
calculates one
these are
value,
the three
not that R
users in the
star or
network,
not
in the
that
GAP
R
network,
S.
A,
That
B,
is
and
the
C.
R and R star,
Okay.
the correlation
Now,
coefficient is
these
applicable to
directed
Pearson and
edges
Spearman. So here it
shows
values chi-square.
like
And this chi-square
how
value
many
is not
posts
necessarily within
of
+1 and
a
-1.
particular
So it is a
user
little bit
has
different
some other
because
user
it has the different range
reposted.
of values.
So take
So
for
it
example
gives you the chi-square
the
values calculation.
case of this
Now let us
user
consider.
C.
Now you have
User
given a set
C
of attributes,
has
two attributes, for example,
himself
A
or
and B,
herself
and all the
posted 10
attributes are
messages,
within the set of values,
and
range of values
the
A1
same
to
user
AN,
C
and B
has
attributes given the set of
reposted
values B1 to
some
AN.
5
And you have the
messages
tabular data,
from
and then we have to
user
find the
A,
chi-square
okay,
values
coming from
between A
user
and
A.
B.
So
What is the
user
procedure that I
C
wanted to
has in
say?
total,
For the
you can
given
imagine,
values, we have to
posted
find a
15
table.
messages,
It is just
out
like
of
a
which
Spearman analysis
10
table, we call
are
a
its
contingency
own
table.
messages
But this
and
contingency
5
table is
are
bit
those that
different.
have
Okay,
come
so
from
from the
A.
table,
Now
you have to
user
find
A
what is the
does not
co-occurrence of
repost
the
the
two values.
post
So
of
for example,
any other
AI,
users
AI
as
is
per
one
this
value of the
network.
attribute
It
A,
has
and
only
BJ is
posted
another value of the
by
attribute
itself.
BJ,
It has posted 17
capital B.
messages by
And then
itself.
co-occurrence means
Okay.
what? How
User
many
B
entries are
has
there, for
not
which
posted
there
any
is
message,
a
but it has
values of A
reposted
equals
3
to AI
messages from
and values
C,
of B equals to
and it has
BJ.
reposted
So this
9
entry we
messages from
can store here. So
all
the
of its
entire
posts.
data that is
So
given to
this is what
you,
is called
we
a
shall be able
repost
to
network.
calculate how many
Now
entries are
from the
there, that
repost
where
network,
AI and
we
BJ are
construct
the pair
the
of
belief
values.
network.
So
You see
similarly,
how the
for
belief is
A1, B1,
constructed.
A, and
So
for all
what
type of
we
values,
do
we can find the
is
code. So
say
this table,
C
you
has
can see
posted
it has
15
n
messages in all, as I
dimension,
said.
n
Out
rows,
of
and
that,
n column.
10
Where n
messages are
rows
posted
is
by
decided
C
by how many different values of
itself,
A
and
that is
5 are
possible for the
reposted
attribute
from
A,
A.
and
So
B
then
n the
the
dimension
belief
of
of
the
C is
attribute B,
computed as
how many different
10
values of
by
B that is
10
possible
plus
for the
5.
attribute
That
B.
is 10 by
There
15,
are two, right?
which
So
is
M and N, that will
0.67.
decide
Okay.
how many rows will
And
be
the
there.
belief of
So
C
M rows
on
are there
A
for each
is
different values of the
5 by
attribute A,
15,
and
that is
N columns are there for
0.33.
each different
In
values
this
of the
way,
attribute
the
B.
belief of
And
B
then the
on
entry in
C
this scores,
the belief
we
of
can
B
find that
on
how
A
many
and the belief
INTs
of
are there,
A
how many
on
data
A
are there
are
for
all
which A
computed.
equals to AI
Okay.
and B equals
So
to
and
BJ.
now you
This
have
entries is
different
called the
scores,
observed
belief
frequency.
scores on
So
the
this is the object
different
frequency
edges,
that can be
and you also
calculated.
see
Anyway,
the
so this is about the
direction of
contingency
the
table
edges
of
have changed.
site
Okay,
n cross
so
n.
now
The
the
psi will be
direction has
decided
become
by
opposite. So this
the
means
values of
that
attributes
C
that
believes in
the
itself
attributes may have.
to an extent of
Okay, so as
0.6.
I said that, okay, entry is called the
Okay,
object
0 to 1,
frequency. So
and
it will calculate
it
even a
believes
set of value
it has a
like,
belief of
so if
0.33
this is
on
the
A
data,
on
the
a scale of
population that is
0
given to
to
you,
1.
right?
In this
And then
way,
we
you
shall be able
compute
to
the belief
calculate
of each of the individual
OIJ for
nodes
all
in
values
the
of I and
network.
for all values of J.
So once you have
That means for
computed
all values of A
the
and for all values of
belief
B, right? So
network,
OIJ can be
you run
calculated.
the
So this way, the all entries in
diffusion
the
model.
table can be
Okay,
obtained
so
once
we
we
run a
can
very
scan the
simple
entire
D-Roots
data.
model.
So OIJ
So
can be
what does
calculated
it
for
do?
any
Let
ith
us
and
say
jth
that
values
this
of
node
A and B
A
respectively.
is a
And this is called object
node
frequency.
from the
In addition to this
seed
object
set of
frequency,
headful
we
users.
shall be able
Okay,
to
so I
calculate
told
another
you that
frequency called the
in the
expected
beginning we have
frequency.
prepared
What
a
is the
seed
expected
set.
frequency?
So let's say A
Now
be a
here,
part of that seed
total
set,
sum of the
and
rows, that means
therefore
row
we
total.
set the
So
score of
this
A to
implies
1.
that how
Okay,
many
so as we said
data
that
are there
for
for
the
which A equals to AI. So this gives you
users who
the
are
row
part
total
of
for
the
AI. Similarly,
seed
for
set,
all values
all
of
of
A
their
in
scores
the
will be
data set,
1.
how many
All the
of the
other
values of A
users' score
having
would be
a particular
0.
value will
So
be obtained
therefore,
from the row
in this
total.
case, let
Like
us
row
set the
total, there is also
score of
column total.
the
Column total
node
means in the
A
data that is
to
given to you,
1
how many
because it is
entries are
part of
there
the
for which
seed
B,
set,
capital
and
B is
rest
equals to
of the
B1. So it
users
is a
in
column
this
1.
network have a score
Second
of
column total
0.
1, and this
Now
way.
we
And if we take all the row totals and
the
then all column totals
scores of the
together, then
other
it is
nodes.
actually
So
give the
the
grand total. Grand
score
total means how many
of
total data
the
point that is
node
given to you.
C, the belief
So
score of the node C
this
at
calculation,
time I plus
okay,
1
useful to obtain
is
another
computed
frequency is
as
called the
the
expected
score of
frequency.
the
So expected
node
frequency is, for example,
A
for the ith
at
row and
time
jth
I
column, we
into
have already calculated
0.33
object
because
frequency.
the
We shall
belief
be
of
able to
C on
calculate the
A
expected
is
frequency
only
like this. It
0.33
is row
out of a
total
scale of
for
0 to
that
1
ith row,
plus
and for the,
0.67
if it is the
into
EIJ to be calculated, so
the
the jth
score
column,
of
the column total,
C.
so
So
AI into
initially,
BJ,
if
this
you
is the
look at the
formula,
first
divided by
iteration,
total number of data that is
B
given to you.
of
So AI
C
into BJ by
at
N. So
time
this
1,
way, EIJ
so
for the
let's say I is equal to
entire
0, at
right
time
row
1 is
entries
equal
can be
to
obtained. Therefore,
0.33
given a set of
into
data, we shall be able to
BA0.
calculate both
BA0,
object
as we have
frequency and
said
row
that we
frequency, and
set
that is required,
BA0
right?
to 1
So object frequency and
because
expected
A is
frequency
a
it will be
part of the
calculated.
headful
Once we have, then we shall be able to
user
calculate
set.
the chi-square
Okay,
value.
so this
And
is
this
1
formula for
plus
calculating chi-square value
0.67 into
is like this. So it
BC0,
is
which
all
is
object
0, because
frequency,
all other
right,
nodes apart from
minus
A has a
EIJ whole
belief
square
score of
divided by
0. So
EIJ,
therefore,
taking for all values of BI in
BC1
the
is
table, that is the
0.33.
contingency
This
table.
part
I
becomes
can
0.
tell one example so that you can understand
Therefore,
about it.
the score is
So chi-square
0.33.
test, actually
Now,
it
in
is
every
also correlation
iteration,
analysis
you
in the
keep
form of
on
a test like sphere and
computing.
correlation
You
also.
go
It says
iteration by
that,
iteration,
the
and you
attributes
keep
that
on
needs to be checked,
computing
for
the
example, A and
belief
B,
scores of
we
each of
assume
the
that they are
individual
independent.
nodes.
They are
And you
independent means there
stop
is no
at a
relation.
point
Okay,
when
again, it is just
convergence
like
is
a null
reached.
hypothesis
That
as
is,
we have
the
already
scores
considered
of the
in the
different nodes do
Spearman
not
analysis,
change
is that
anymore.
A and B
Okay,
are
so
independent.
at
So it is the null
convergence,
hypothesis that we
all the
assume.
nodes which
And this
have a
null
score
hypothesis has the
from
degree of
0.7
freedom.
to
The
1,
degree of
we
freedom in
call
this
them
case, if the n
K8
rows
or
and n
known
columns
height
are involved, so
users,
degree of
and
freedom is n
all
minus
those
1 into
which
n
have a score
minus
from
m minus
0
1.
to
So that is the degree of
0.25,
freedom.
we
That is
call
for
them
this table of
non-height
data.
users.
So in case of data analytics, the degree of freedom is an
So now
important
we have
method.
used,
And then
as
for
you
the
see, we
different
have
size
used
of
an
the data, degree of
unsupervised
freedom
mechanism to find
calculation is the
out
different
the
formulas are there.
hateful and the
For example,
non-hateful users.
n
Those
univariate
that are
population of
in
size
the range
n,
of
the degree of freedom n minus 1.
0.75 to 1,
Two
we
column
call
n
them
minus 2,
hateful, and
and
those
a
that are
table
in
of
the range
n
of
rows and n column, the degree of freedom
0
is
to
n minus 1 into n
0.00
minus 1.
to
So this is the idea about it, right?
0.25,
Now we have to test
we
whether
call
A
them
and B are
non-hateful.
independent or
Now
not. That means
we
the
ask
null hypothesis
two
to be accepted or
annotators,
rejected.
two human
If we
annotators,
accept it,
to
then there is no relation.
check
That means there is no
that
correlation.
whether
If we
whatever we
reject
have
it, then we can say
identified
that
is
A and
correct
B
or
are
not.
independent, right? And then the
Annotators tell
they
us
are
that
dependent,
with
right?
very
Or
high
strongly
confidence
correlated,
that
we can
they
say.
are
Okay,
sure
so let's see
that
whether we can
whatever they have
accept the hypothesis or not.
identified,
An example we can
whatever we have
consider.
identified using
consider
the
one
simple
table that is based on a survey, the survey on gender versus office. Suppose
propagation
we conduct a
algorithm,
survey
the
among a
degrowth
population of
algorithm
size 1,500. So in
is
this case, N is
reasonably good.
1,500.
So the
And in
annotator
this survey,
1
gender of each
agrees
person and their
in
hobbies. Hobbies
87%
may
of
be
the
either book
cases
or
with our
computer. And
predictions.
you, okay,
And
I've
annotator
noted.
2
And you
agrees in
see the gender is
93% of the
again
cases
categorical
with our
attribute because value
prediction.
is M on
For
F.
the
And the
hateful
hobby only two
users,
type of value
for
we
the
have considered.
non-hateful
You can
users,
consider
the
more other
annotator
hobbies
1
also,
agrees in
book, computer,
92% and
TV,
the annotator
and
2
then many
agrees
other
in
sports also we can.
99%.
But
And
here,
there
for
is
example,
a
consider
reasonably
only
high
two
agreement
attribute values,
between
book
the
and
two
computer.
annotators.
Okay,
Okay,
so
measured
it is
by
a
the
categorical
Kappa
attributes.
score.
Now we want to check.
So that
We
this
want to check
gives
whether
us
gender and
some
hobby are
faith that
independent or
the
not. So initially we assume
hateful and the
that there
non-hateful
is no
users
relationship
whom we
among
have
gender and hobby. They
identified
are independent.
are
Okay, now we have to test
of
this
reasonably
hypothesis
good
using
quality.
chi-square analysis.
We
So
did
what we
further
want is that
experiments
if a
to
table of
actually,
given to you with a
corroborate this
1,500 row like this,
hypothesis
I have
in a
not
more
included
stronger
all the
way.
data.
So we
From this
take
table,
all the
we shall be
topics
able to
in
create
which
our
the
contingency table.
hateful
In this case,
users
contingency
post,
table,
and we
here
also
the attribute, this is the attribute has only
in
two
which
values,
non-hateful
and here
users
this
post.
attribute has
So
the two
like in
values.
Twitter,
So two
in
rows and
GAMP
two columns
also,
for the two different attributes are there. So it is
users
a 2
can
cross 2
post in
table.
different topics.
So let this is the
And
gender
the
and this is the
hateful users
hobby.
that
That
we
one
have found
attribute is
out,
gender, another
they
hobby is
seem to post
and
in
book
very
and computer is
sensitive
a male and
topics
female.
like
So it is just a
Jews
B1,
are
B2,
the
A1, A2.
synagogue of
Okay.
Saturn, the
And
black
then
race
here
sucks.
we can
These are
what we can understand that these
extremely
are
hateful
250 the
topics,
object frequency.
as the
That
name
means
itself
out of
suggests. Okay,
1,500,
and
we
whereas
see
the
200
non-hateful
people,
users
though the
typically,
gender is male and their hobby is book. And then
post
out
in
of 1,500,
topics
we can
which do not
see
seem
that
to have
gender
any
is female
hateful
and then book
connotation as
hobby,
such.
their hobby is book. Similarly, other
Last,
entries.
again, there is
And also
another
we can
set of
see
experiments
total
that we do to
entries
further
for which the
corroborate
hobby is
our
book is 450, whereas
observations.
hobby is 1050.
We try to see
Similarly, how many
what are
total
the
male
different
in the survey?
URLs
300.
that the
Total
two
female is
sets of
1200.
users are
So total
sharing.
is
What are the
1500 is the
URLs
total
that
number
the
of
hate
records that we
users
have
are
taken.
sharing, and what are the
Okay,
URLs that the
so this is the
non-hate users
contingency
are
table,
sharing.
and
We
these are
see
the
that there
object
are
frequency.
quite
You
a
can
few
see
URLs
011, 012,
that
021,
actually
022. These are the four entries are
express
there. So object
views
frequencies
from
are
the
calculated.
far
Now we
right
shall be able to calculate expected
community.
frequency.
Okay,
It is very
so
simple.
some of the
For this,
newspaper
write
names that you
E11,
find here on
450 into 300
that are
divided by
posted by the
1500.
hateful
Similarly, E12
users.
also can
If you
be
do a
450
simple
on
Google search,
1200
you will
divided
find
by
that many of
150.
them are
So this way,
actually
these are the expected frequency
spokesperson of
calculation. As you
the
can see, you
far
can check
right
it that this is the result.
supporters.
So from the given table
So
like
this
this,
actually gives
right,
us
we
a
shall be
pretty
able to
good
calculate
confidence
object
that
frequency,
whatever
and then also we shall
have
be able to
found
calculate the expected
using a
frequency.
very
And
simple
once these
diffusion
two
model
frequency values are calculated,
is
we
a
shall
good
be able to
representative
calculate the
of the
chi-square value
hate
using
and
this
the
formula.
non-hate
And you can
users.
note that chi-square value
Now
formula,
what we do
it
with
is
them?
this one formula.
So you
So
remember
Oij minus
initially I
Eij whole
asked
square
the
divided by
question
Eij.
that
So let's come
what
here.
happens if
So this is the
we
formula
allow
Oij minus
users to
Eij
spread
for the
hateful
first
messages
O11
on
minus
a
E11
platform
whole
like
square
GAP,
divided by
which
E11.
is
For the
like very
second
loosely moderated.
O12 minus
Okay,
E12
so does it spread
by
faster
E12
than normal
by square
message?
by
Does it
E12 like
spread
this one.
slower
Okay.
than the normal
And
message?
here
What
for this
happens?
given data, the
In order
chi-square
to
value that can be
see what
obtained is
happens in particular,
507.93.
what we
So this is
study
the chi-square
is
value that we have
what are
obtained.
called cascades in
Now
the
we
scientific
need to
literature.
test
Okay,
whether
so
this
these are paths
prove the
traced by
hypothesis
a
or
post
reject the
as it is
hypothesis,
reposted by the
right?
users.
Now again,
Okay.
there is a
However,
statistical
it is
table like t-test
impossible
table.
to trace
There is
the
a one table
exact
called the
influence
chi-square
path.
table.
This is a
Chi-square
difficult
table
task,
that can be
and therefore
consulted with degrees of freedom, and then
I will talk
degrees of
about it in
freedom
the next slide.
for the
Some
different degrees of
heuristics which
freedom,
we
and
will
then the
use
chi-square value
to
can be
actually trace
consulted.
the influence path
Here,
and
this value
see
needs to be
how the
compared.
message
Now,
is
for this
spreading.
table, as we see n equals
Now
to 2
again,
and m
let
equals
us
to 2. So, degrees of
consider
freedom in this
a
case
small
is n
portion of
minus
the
1 into n
gap
minus 1.
network.
That means degrees
Let
of
us
freedom
say
is
we
1.
have this
So, the
nodes
chi-square
A,
table
B,
that
C,
needs to
D,
be
and E, these
consulted
5 nodes
with 1
in the
degree of freedom.
gap
So,
network,
for
and these
every degree of
edges
freedom,
that
there
you
is a
see
different
here
value of
are the
chi-square.
follower-following links.
Now, for
Okay,
one
so
degree of
this link
freedom, the
indicates
statistical
that
chi-square
C
table
follows
with
A. This link
0.01
indicates that
significance level is
B
equal to
follows
1%
A,
level
and
of
this link
significance, you can
indicates that
say.
C also
So, chi-square
follows
table
B, and
needs to be
so on and so
consulted with degrees of
Now,
freedom, and
let's
then
say that
what is
there
called
is
the
a
level of
message
significance.
that
That is the
was
confidence
posted by
actually, confidence level.
the
So 1% confidence level is
user
equals to the
A
value
at time
0.01.
point 0.
So
Okay.
if with
User
it is a
B
two-dimensional
had
table look
received
like, so degrees of freedom
at
and
time
level
point
and
100.
confidence
User
level,
C
then
has
this value
received the
gives
message
that
at time point
10.828.
300. User
Now
D has
10.82 is the
received the message
statistical
at
value,
time point
and then
500,
observed value
and
is
user E has received the
507.93,
message at time
and
point
this
400.
observed value is higher
Now,
than this one. So
question
this means
is,
that
like,
this
since
chi-square value
C
that
has
is obtained
received the
for the
message,
data, it is
okay,
rejectable.
at a time
So
point
rejectable means
after
initially
E
the
has
hypothesis
received
is
the
now that
message,
there is no
the question
relation,
is,
but it is rejected.
did
That
C
means it says
receive
that
the
there is a
message from
relation,
B,
and this
or
value
did
is
it receive the
very
message from
high
A?
compared to
Okay,
this.
because both
This
of
is
them
a
have received
limiting
the
value. Then
message
we can
before
say they are
C,
strongly
and
correlated.
now we have to decide
And
that
then this is up to the confidence level
from
1%.
whom did
We can
C
check that,
actually
okay, even
receive the
for 1
message.
degree there is
Did it
also
receive
another
it from
confidence
A,
level. We can
or
check
did it
about
receive it from B? This is where we have to
0.001 also you can check, and
actually
then you can say it's
use a
confidence up to
heuristic,
that level
because
also.
finding
So
the
as
exact path is
this significance
intractable.
level value
Okay,
is
so
decreases,
what
the
we
confidence
assume in this
increases. This
case
is the reverse
is
thing,
a
right? And then
least
we can say
recent
that it is that
influencer
kind of
model.
confidence.
That
Regarding
is,
confidence level
we
and everything,
assume
we shall
that
discuss in details
C
tomorrow.
must
We will be
have
able to
received the
understand about it.
message
Anyway,
from
so
the
this is the
person
idea about the
among its
chi-square test, and then we can see how it is applicable.
who has first
Okay,
posted
so
that
we have
message.
discussed about
So
one
among B and
methodology.
E,
This
sorry,
methodology
among
is
B and
regarding the
A has
relationship
posted the
analysis,
message earlier,
and two
and
methods,
therefore we
as I told
assume
you.
that
One is
C has
correlation
received the
analysis, which you
message
have learned,
from
right? And then
A.
next is called
Okay,
regression
so
analysis.
you can also
So let's start
consider
about
the
this.
other
It is
way
very
round,
interesting,
that is,
and you can remember I have
rather than the
started with one
LRIF
challenge.
model,
That
you can
means you
have
have
the
given a 50
MRIF
points or
model, which is the
500
most
points, like
recent
how we
influencer
can
model.
represent this one.
Okay,
That means how from the given set
that
of
it is
population
from
data,
B that
how we can
C
build a
receives the
model.
message.
So regression
Okay, so we
analysis is
used
the
both
first
of
of
this,
its machine
and the
learning
results don't
concept,
differ
which we
much.
can use to
Okay,
calculate,
so
we can predict, rather
here
we
we
can
will show the
predict
results
or a
only
unknown
for
value,
the
what is the value.
LRIF case,
Okay, so
but for the
unknown value
MRIF
is
case
x
also
and
the
then known
results
value
do
is
not
y.
differ much.
So for a unknown
So
known
once
value
we
is
have
x,
traced
unknown
this
value is y.
influence path,
So for a known
we
value
can
x, that means
actually
input, what is the
convert
prediction?
the
That means it is the
graph, the
prediction.
directed
Okay,
graph
let's
that you
see
have seen in
with
the
the
earlier
regression
slide
analysis,
into a DAG.
the
Okay, a
regression
directed
analysis concept first,
acyclic
and
graph.
then
There is no cycle
we
in
shall
this,
discuss about
and
how
these
we
edges
can apply it.
actually now trace the influence paths.
There are
So that
different
this
type of
shows that
regression
C has received the
models that
message
we
from
can think
A,
about.
E has
And
received the message
if
from C,
only,
D
so
has
there is a
received the
concept,
message from
one is
D,
called
and
the
D has
dependent
received the message
variables
from
and then
E. So
independent
you
variables. For
directly know
example,
now the
if we
influence
want
path, that is
to
from
take the
whom the
values
message
of
has been
a, y,
received, who has
or
received the
a
message
given
from
value of
whom.
x, then we
Okay,
say that x is
now we
dependent
find
and
out
y is
the
independent. Sorry,
cascades
x is
generated by the
independent and
posts
y is
of the
dependent values.
known
Okay.
hate users,
Now
as well as the
there is also
cascades generated
possibilities
by
that
the
the
posts
y
of the
depends
non-hate
on not
users,
only a
and
single
we
value,
compare these
but it depends
cascades.
on
Okay,
two
we
or more
compare these
values.
influence paths.
So if y
Now these
depends on
cascade
only
properties
one
can be studied
independent
by
value, then it is called a simple regression.
different metrics from this
So
directed
in this
acyclic graph.
figure, we see
One is the
y
size, that
depends
is
on
the number
only
of
one single value. So
unique
it is called a
members, or the
simple
number of unique
regression.
users in this
But
DAG.
here y depends on
Depth,
xz,
which is the largest
so
part
it
in the
is called the
cascade.
multiple
Okay,
regression. But
average
it
depth,
also can
which is
be
the
extended
average
to
depth
y
of each
depends
path
on
from the root
wx,
node.
date, and
Okay,
so on. So there is
maximum
no limit of dimension.
width of the
So is
cascade,
it two
that is the
dimension,
breadth.
three
So you go
dimension,
level by
whatever it
level,
is.
and
But
you
if it is
see
a one
what is the
dimension, called
maximum
simple
span
regression.
at
If
any
it is a
level.
multiple
Okay,
dimension, they
and
are
that
called
span
multiple
is
regression.
actually called the breadth.
Now,
Okay,
regression
and
can be again
structural
linear and
virality
non-linear.
is
So
actually
if
the
all
inverse of the
points
distance
that
between all
is
pairs
given to
of
you,
nodes in the
or which
DAG.
a straight
Okay,
line can
so
be
these are
just look
some
like
of
a
the
model,
standard
then it is
measures
called the linear
that
regression. So this
you
is one
extract
example of a linear
from the
regression. This is also linear
influence
regression. So it is a
paths
linear
or the
regression with
cascades.
simple
And
regression
what do
only.
we
So it is
see?
called simple linear regression. And this is again linear regression, but with
So we do
multiple
the
values are
experiments
involved. So it
at
is
three
called the
levels.
multiple linear
We take the
regression. So it is
original
bivariate, it
posts
is
of
then
the
multivariate, you can say.
hateful
And
and the non-hateful
again here,
users.
if
We
the
take the
regression
posts
model
containing
that we have
attachments
to
like media
obtain, it
or
is not a
images
straight line
in
like
the
this one, but it is a
hateful
not a
users
line,
post,
rather it is a
and we
graph.
also
Then that is called the
consider the
non-linear regression.
posts in different
If it is a line like, then it is a
the
linear. If it is
topics last
not a
time.
line,
Okay,
then
there
it
are
is called a
different topics in
non-linear.
the hateful use
So all
in
the regression analysis
gap
can be
platform where
therefore
the hateful
classified
and the
into
non-hateful
two
user
broad
blog post. So we do
One is
the
linear and
study at
non-linear.
different levels.
Then under
We
linear,
study the
simple linear or
cascades
multiple
at
linear.
the
Again,
original
for
post
non-linear,
level
again
of
simple
the user,
non-linear,
at
simple
the
non-linear
post
as well as
containing
multiple non-linear. So
media
four different
like
type of
images
regression
or
analysis
videos,
is possible.
and at the
So let us
level
first
of
start
the
with
different
simple
topics.
linear regression model.
Now what do we see?
Now, what is the
So if
idea?
we look
Idea
at
is
just
you have
at the
given a
level of
population data by immediate data,
textual
for example,
posts,
that means only
we
X and Y
see
are
that
involved.
all the
Then you have to
metrics,
find a model.
size,
That
depth,
model in the
breadth,
form of a straight
average
line.
depth,
So let the equation of the
structural
straight line in the
vitality,
generalized
for
form we can
all
say Y
of
equals
them,
to
the
A plus B, alpha plus beta X. As I already said that
of the
alpha and beta are the model
non-hateful
parameter. These are
users
the values to be learned.
are
So these are values to be learned from the given set
non-hateful
of points so
users.
that this
You see,
line
all
can
of
be
them are
obtained.
larger in
And as I
number,
said that
and the
okay, these values
differences
alpha and
are
beta to be learned
statistically
because
significant. We
given
have
a
done
set
the
of
statistical
points,
significance
you can in
test
fact
using the
draw infinite
Kolmogorov
number of
standard
lines.
Kolmogorov
So out of the
test,
infinite number of
and we
lines,
see
we
that
have to
the
select that
two
line
results are
which lines
statistically
have the
significantly
smallest error.
different.
What is the
Okay?
error? So if suppose
And
this is the
now
assumed line we
actually
have drawn
these
and this is the
results
point that is given
are
you. So every point with
get
reference
more
to this
pronounced
line
if you
associated with
look
errors. So
into
this is the
posts with
epsilon 1, epsilon
attachments
2. This is the
and
error. Error
posts in
means
different
what is the
topics.
perpendicular distance
So
from
what
this
we
point on
observe
this
in a
line. So
nutshell,
these are the
that
perpendicular distance
posts
from
of
the point
hateful
on the line.
users
So all these are the very
spread
simple
to a
coordinate
larger
geometry that we
audience,
can
okay,
think
because the
about.
size is
That okay,
large,
assume any
it
straight line
spreads
y equals to
wider,
alpha plus beta
okay,
x and then
because the
calculate
breadth is
errors.
larger, it
But you have to
spreads
find the
deeper
values
into
of
the
alpha and
network,
beta in such
because
a
the
way that these errors
length
should be
or
minimized. That
the
means all the
depth of
errors
the
or summation of all the
cascade
errors
for
or
the
square of the sum of the errors are minimum. Whatever the parameter that you can think
cascades
about.
from
So
formed by the
these
hateful
errors to be
users is
minimized.
much
That means
larger than
in
those of
between
the
the lines
non-hateful
there are
users,
infinite
and they are
number
more
of lines
wider
are
because
possible.
the
Out
structural
of the
virality is
infinite number of
higher.
lines we have to
So for
select that
all these
line which
properties,
has the
for the
minimum
cascades
errors.
of the
So
hateful
this is
users
one what is
are
called the searching
actually
problem we can
dominating
say.
over
So
the
that how
non-hateful
we can
users.
find this minimum
So, and
searching
this,
line
as
is
I
here.
said, is
Now, so
the
this can
signals
be
get
calculated very
only
easily.
stronger
Let us
and more
consider
pronounced if we
the
consider
errors or the
like
sum of the square of
attachments
the
like
errors. That
media
means this is
files,
the yi. Is
such as
yi is the
images
given
and
values of yi
videos,
and yi
and
bar is the
also
predicted
in
value.
case
So
of
it is a
topics.
predicted value and
Okay,
this
so
is the observed
therefore
value we
this
can
gives
say
us
or assumed
enough
value, right?
evidence
Or given
that
value, whatever you
if
can say like this one.
something,
That means it is
some
the
hateful
yi, it is the given data value,
populated in a
right?
platform,
And then
they are going to
minus alpha
spread
minus beta
at a
x is the
much faster and
predicted
at a
value.
much
Okay, so
deeper
it is the
level,
difference between here
okay,
in this
compared
figure.
to any
It is
non-hateful
yi
post.
and it is a predicted value. So predicted value maybe
So
say this a
this
and bx is the
actually
predicted value, right?
uh,
So it's the
tells you
difference between
that
the
how
input values
alarming
and then
the
predicted
spread of
values. Input
hate
value
speech
is called
could
the
be
training data,
in
right?
a
So this
in an
data, this kind of
unmoderated
data are called
platform.
training data. Here, for
Now the
example,
question
they
is
are called training
like
data. So these are the called training data, right?
so
So
if
training
we
data
even
has
want
xi
to
and yi value,
stop
xi
or
and
slow
yi
the
values,
spread of
and
such
this
hateful
is
messages,
your assumed
what can
value.
we do?
That means
What are the
model values
different
or
steps
predicted
that we
value.
can
That means
take
you have to
in
find
order
it.
to
So we can take the
actually
difference
uh,
between
you
this
know
and this. So this way it
have
will give you the
some
errors
sort of
actually,
an
right? So
intervention
if this is the yi
to
bar and this is the
stop
yi,
this
then the difference between the two gives
unmoderated
the error.
spread
So
of
this is the idea.
hate
It is
speech.
there. Okay. So the
So there
error,
has been
any
various
error, the ith
measures
data
that
point,
have been
right? Or the
suggested by
ith
the
data point, the
governments
error can
of
be
different
calculated at
countries,
ei, which is
as
this
well as
formula.
by
And then
taken
we
up by
can take the
different social
square
media
values
platforms.
because it will
Some
nullify
of
the
them are
positive negative
like
sign. So it
block
will
or
give you the
suspend
sum
the
of
hateful
total
message
square of the
on the
error. So
account.
this is why it is
Okay,
called SSE.
several
The
governments
SSE
have
value
come up
can
with
be calculated
established
for
hate speech
all the
laws.
points that is
Okay,
given here.
and
So if your training data
spread
consists of
hate
n number
speech
of points,
on
for
different
each
social
point we
media
shall be able to
platforms.
calculate
It is
errors. So
punishable
this is the
by
error calculation.
cyber law and cyber
Now,
crime
as I said you that okay,
departments. Okay,
there are
then
infinite
there
number of
are
lines possible. For
several
example,
social
if two lines
media
are there, we have to select the baseline.
sites
So what is the
which
way
have
of the baseline? The baseline is
tried to
that the
design
baseline is that
extreme
line that
measures
for
in order
that values
to
of A and B so
uh,
that the SSC value is minimum.
reduce the
That
volume
means we
of
have to find
hate
an
speech.
optimum
Okay,
values of
however, there is
SSC
a
for
problem.
which the error is
Now
minimum.
if
Now, as this is
you
a
take
optimization
such
problem and
very
finding the
stringent
minimum, so we
measures,
can take the
then
first order
the
differential
fundamental
with
rights of
respect to
free
all
speech
unknown. Here,
seems to be
the A and B
violated.
are the two unknown
Okay,
parameters
so
because
people
they are
might
model
come up
parameters. These parameters to be
with
learned.
the
So we can
complaint
take a
that
first order
okay, you are
derivative,
stopping us, you are
first order
suspending us,
derivatives of
you are
SSC with
punishing us
respect to
by
A
law,
as well as
but
B,
then
then we
by
can get
curbing
this
our
one, right?
rights
So this is a very simple
to speak
derivation that
our
you can
mind,
take it
you are
and then we can
actually
find,
also
and this is the formula. So
curbing our
and for
freedom
the
of
minimum
free
value,
speech.
so these
Okay.
phosphorus derivatives will be equals to 0.
So
So
therefore,
this will give
what
rise
could be
to
an
two
alternative?
equations,
What could be a
because
possible
if this is
alternative?
equals to 0
So a
and this is
possible
equals to 0,
alternative
they will be similar
to have
to
more
this one.
speech,
So a into
okay,
a plus b
and that
summation
in
of
the
xi
form of
is equals to yi.
counter
So if
speech.
you take
So
this
if there
is
is
the
some
value,
hate
right?
speech,
Taking the summation
you
of
try
this, so A will
or
be
you
sum
try
for
to
the n
involve
times, so
the
Na
community
plus
to
B
generate
and
speech
then
that
summation of
can
all xi values. So
counter
this is a B
the
into summation of
hate
all xi
speech
value.
posted
This equals to
and
yi
thereby
values. And this is equals
neutralize
to summation
or
of all y values.
subdue
So this will
the
give you this one. Now you
intensity of
see,
the
and
hate
similarly for the
speech. Okay,
second,
and this idea is
also
actually
we
now
can have
promoted by various
for the
organizations,
second
and many
derivatives, if it equals
NGOs
to
have
0,
come
we
up,
can get this is the equation.
to
So
help in
two
promoting and
equations
generating
we shall
counter
be able
speech
to get
data.
it, and these two
Okay,
equations are
so
the two unknown
we
A
did
and B,
a
right?
small
So two
study
equations and two
which was
unknowns.
again
So
published in
this is
ICWS in
actually the two
2019,
systems of
where we
equations with
studied
two linear
countering
equations with two
online hate
unknowns.
speech,
So we
but
can
now
easily
on
solve.
a
We
different
can
social
easily
media
solve for A and
platform,
B because solving two equations are pretty
consisting
easy.
of
And then
the
solving these two
YouTube hateful
values, we
videos.
can obtain
Okay,
A and B value. It
so
is like this one.
our
So
data
A
set
can be
is
obtained using this formula, where Y
formed
bar
from
for
the
the given training
comments
data is a
on
very
the
simplified
hateful
formula
videos
actually
of
for the training
YouTube,
data.
posted on YouTube.
So this
Okay,
is the
now
training
we
data. If
define
you take
counter
all the
speech
yi's
as a
values here
direct
and take the
response
average one,
or a
so it
comment
is yi
that
average.
counters the
And
hateful or
then for all
harmful
x value,
speech.
the x bar.
Okay, so this
So
is
A
how we
equals to y bar
define the
minus b x
counter
bar.
speech,
Now
and
B
we
can be
take
calculated
YouTube
using this one. It is sum of
as an
that
example,
is a product
and
of the
we look
difference
into
of each
three
age value
target
with reference
communities:
to their
the
mean.
Jews,
And then
the
it is
African
just like a
American
covariance
blacks,
formula, it is
and the
called.
LGBT
And divided
community,
by
and
is
we
a
collect
sum of the
data
square of the
from
xi
user
values
comments,
with reference
create
to
a
their
data
mean.
set that consists
So
of
this way,
counter
so
speech
here
data,
you see
and
all
then
are
do
unknown
a
because xi, yi
cross-sectional
for I equals to
analysis to
1 to
see
n. This is the
if
n
this
data point that
counter
is
speech
given to you.
actually
Given the
helps,
n
and
data
if
point,
so,
x bar,
how.
y bar can be calculated.
So these are some
Therefore,
of
B
the
can be calculated.
videos
Once
that
the
we
B
have
is
collected. These
known,
are some of the
then we shall
example
be able to
videos
calculate
that we
A
have
in terms of
collected.
y bar and
Okay,
x bar.
so
And
these
B
are
is also
31
known,
in
right?
number,
So this way
and
A
we
and
have
B can be
scraped
calculated.
all the
So A and B
comments
can be
that are
calculated means
associated, the
we shall
prime
be able to
comments that are
calculate the model
associated
parameter. So
with
Y is known.
each of
So
these
out of the
hateful
several
videos,
equations,
and this
we shall
form
be able
our
to find the
data
best
set.
equation.
Okay,
Best equation in
now
such a
counter
way that
speech
this
can be
error
of
is
different
minimum.
types.
This error
Okay,
is
it
minimum.
could be
Okay, and
like
this
by
is the
presenting facts
line,
to
that
correct
parameter, that
the
is the model. So we
misperceptions.
therefore able to
Okay,
line the curve.
somebody
So you can now
might
recall the challenge that we
put a
have given
hateful speech
initially. We have
or
given a set
post a
of point
hateful
50 or 500,
speech
how we can
by invoking something
represents the
that is a
values of A and B.
misinformation
This is
or
because
a
it is the
false
formula that
information.
Y equals
You can actually
to
then
A
counter
plus
the speech
BX.
by
So for
presenting the
A
correct
unknown
fact.
X, we
That is
shall
what
be
is
able
called
to know the
presenting
values of
facts
Y.
to
That means is a prediction. That means for A unknown values of X, we shall be able to
contradictions
predict what
in
is the
the
values of Y,
hate speech
and that is
itself.
in terms of
Then warning
two
of
known parameters
offline or
called model
online
parameter A
consequences,
and
that
B.
you tell the
So this
person
is the idea
who
about
is
the
posting,
simple
tell the
linear
person or the
regression
group
analysis.
who are
Now
posting
again we have to check
hate
that
speech,
whether this
you tell
simple
them
linear
that this
regression
is punishable
analysis
by law,
how good
and therefore
that we
such
have. That
posts
means
should
we can
not be
find it the
made on
different
the
straight line
social
look
media
like. So we
platform. So
have to
this is
check that
warning
for the
by
authenticity of the
offline or
result
online
or
consequences.
significant
Then
test we can say
affiliation.
again.
So
So to do
here
these things,
you try
this
to
quantity called R square. R
take
square is called the coefficient of
the
determination,
side of a
right?
particular,
Coefficient of determination.
say, religious
This is also
minority
applicable to
from
Pearson
a
and then Karl's
particular
Spearman
affiliated
coefficient also.
religious
R
group.
value and taking
Say,
the
for
square value.
instance,
So they will give you the
a
coefficient determination. For
Christian
example, in case of Karl Pearson, say
can
R equals to
support a
0.9.
Jew
And what is the
community
R square? R
by
square is a 0.81.
writing a
So what it
counter
actually
speech
physically
to a
implies, the
hate
R square
speech
is
written by
that
another Christian
how
person.
the
Okay,
variance
so
of the
suppose a
values are
Christian person
there.
has written a
If the
hate
higher
speech which
variance,
is
it is called
targeted
the data
toward
are very
the Jew
fluctuating. That
community.
means it
Now
is not
there
so
can be other
correlated. If the smaller covariance, then you can say that
Christians who can
it is
stand up
less
against
correlated,
this
right?
particular
And so this
Christian
way the coefficient
who
determination
wrote
can be
this hate
considered
speech
that
and
for the
say
model that we
that,
have
okay,
calculated, how good
whatever you
this
are
model
telling
is.
is not correct. I
Now to
am with
calculate it, we can
the
calculate
Christian
SSC.
community, and
SSC
I
is
disbelieve
YI
your
for your
hatred
known data, and Y
message
dash
against
is
the
basically
Jews.
your
Okay, so this is what is
predicted data.
affiliation.
So take the
Then
difference
denouncing
between the
hateful or
two whole
dangerous
square or all
speech.
end
This from the name
SSC.
itself, it is
And in
clear
addition to
that you
this, we
try to
can calculate
denounce. Then you
SST.
also use humor
SST
or
is
sarcasm
YI and then Y
to
mean. That is the mean of all the Y
actually
values.
mock
And so
the
these two
hateful
methods,
speaker and
and
the
R
hateful
square in this
speech,
case can be
telling that whatever
calculated
you are
is
telling
equals to
is
1 minus
ridiculous,
SSC by
or you can
SST.
use a positive tone
Now, if
and say
SSC
that
is equals to 0, that means if there is no
the
error,
community should be
right,
treated
then
in a
R square
more
equals to 1. That means
cordial
it is
and
a
a
best fit.
sympathetic and an
So that
empathetic
is a
way,
very good.
rather than
And on the
spitting
other
out
hand, if SSC
hate
is
speech.
equals to
Or
SST, that
this
means
is something
they
like
are random look like, okay, then
use hate
this is
speech
equals to 1,
in
the R square equals to 0.
return to
That
hate
means they
speech.
are very
So you
cohesive.
use
So R square
hostile
value
language
varies between
in order
0
to
and 1,
counter hate
and it
speech.
tells
Okay.
you that how
However,
the
this
model
hate
is strong.
measure
That means how
is
the
not a very
correlation that you
recommended
have obtained
way of
is that
doing
valid.
things.
So this is the simple linear
So
regression
we collected
analysis.
data.
And
So we
like
scraped
this,
the YouTube
likewise, we
comments,
can
okay, for
obtain the
all these
multiple
31
linear
videos,
regression, because if
and
we
then
can
we
learn
did
the simple linear
annotations
regression,
at two
learning the
levels.
multiple linear
At the
regression
first
also will
level,
not take much time about it. Now, what is
annotated
the
the
idea of
comment
the
as
multiple
whether
linear
it's a
regression
counter
is
speech
that in
or a
case of simple
non-counter
linear
speech.
regression, you
As you
know
see, the
that
data is
the
almost
regression
roughly
between
equal.
x and y. So
There are
one single
7,000
variable and then
counter
one
speech
unknown
data
variable,
points
right?
and
So
7,000
y to
non-counter
be
speech data
learned
points.
in terms
And the
of x
agreement between
only,
the
and then there
annotators
are two
is
model
pretty
parameters,
high.
alpha and
The
beta
Cohen's
value, or
kappa is
AB,
around
whatever it is.
0.8.
Okay. Now multiple
And
linear
then in the
regression, it
second level,
is if there
we
is a k different
do
dimensions of the
further
input variable. That
classification
means we have
of
to
the
predict y in terms
counter
of
speech
k
data.
different
So the 7,000 counter speech
values.
data points that
Given
we
k different
found,
values,
we further
then we have to
classified
predict
it
the
into
unknown
all
value,
these
right?
different
And then this
categories.
is
And here
multivariate
again, the
population, we can say,
kappa
so
value that
k,
we
right,
observed
dimension.
is around
Now, such a
0.87,
model that
which is
can be
pretty high.
represented, if it is a linear, that means if
So
we can
now
pass a
we
straight
look
line,
into the
and it is actually the higher
distribution.
dimension
So
data, because
for
k
different
dimensions are involved.
communities,
So
we
it is
see
actually k
different
plus 1,
amount
because
of
k
hate
is the
speech,
input
counter
dimension
speech
and y is
posted.
the another dimension. So total k plus
But
1
one
dimension
thing to
is
note
there.
is
So in that
that
case, we have
for all
to
the communities, the Jews, the
predict, or we
blacks, the
have to learn
LGBT, the
k plus
largest
1 unknown
number of
values. For example, in
counter
case of two
speech post
dimension, we have to
is
learn two
posted in the
unknown, A
hostile
and B.
category.
But
That
here,
means
in
people
k plus 1
who are
unknown, if it is a k plus 1 dimension data,
trying to do
that
it
means
by
beta 0,
posting
beta
more
1,
hate
beta 2,
speech
dot beta k needs to be
in
learned.
response to the hateful video.
So this is
However,
your
this,
model
as I
actually.
said, is
So this is your
not
model
a very
in case of
recommended video.
multiple linear
Sorry,
regression
not a
is
very
concerned.
recommended
Okay, that
mechanism,
means given a
because
set of
that
points,
actually,
like here obviously my
could be a reason
multi-dimensional
for
point it is given
further
to you.
hostility
So there is a
and
table, it
maybe
is given
an
x1,
offline
x2,
violence.
xk,
Okay.
and y value.
So
And so
therefore,
this is your training data.
this
So
should be
maybe
avoided.
50 or
However,
500 or
if we
5000, this
for
kind
the
of
time
multivariate
being,
data that is
if we
given to you,
do not
and then you have to
consider the
predict
hostile
yi, and to
language,
predict it, you have
we
to
see
learn
a
the
very
model parameter
intriguing
beta 0, beta
observation.
1, beta 2,
There
beta
are
k.
certain
Now, how this
categories
model
of
parameter
counter
can be
speech
learned? What is the
that
method?
seem to
The
work
same method
better
that we have
in
already learned
certain
for simple linear
groups or
regression
certain
can
communities.
also be
For
applied to
instance,
this case
in
also.
the
Now, here how we can do that. So we again, like the
LGBT
previous one, we
community,
will be able to
as you
calculate
see,
SSE I
pointing
equals to
out
1 when
hypocrisy
EI,
and
and this is
contradiction
also same formula
and
YI for the
humor.
given data,
These are the
and this
two
is the
types
predicted
of
assume,
counter
right?
speech
This
messages
predicted assume,
that
this is the
seem to
predicted assume line.
be very, very prevalent.
So we shall be
Okay, if
able
you
to
leave for the
find
time being the
SSE value for
hostile
n
language
different
thing,
point
the other
according to this
two
formula, n
very
different point, and
important
taking the
categories of
first order
counter speech
derivatives with
that are
respect to beta
pretty
0
prevalent
of this SSE equals to
in
0, it will give
countering
one
hate
equation.
videos
Similarly,
against the
this first order
LGBT
derivatives with
community
respect to
are
beta 1, it will give you another
pointing to
equation.
hypocrisy
So this
and
way, so many
humor.
unknowns and so
Whereas
many
for the
equations could be
black
obtained. So
community,
if there
it
are
is
n
warning
unknowns,
of
if
offline
there are
or
k
online
unknowns,
consequences. That is, the
right,
counter
and we
speech
shall be able to
users are
obtain the
telling the
k
hate
equations. They
video
are all
makers,
linear
hateful
equations.
video
So these are
makers,
the
that
equations look
these
like this.
could be
So it
punishable
is
by law.
n beta 0
Okay,
plus beta 1,
and for the
beta
Jews,
2, beta
it
k.
is
This is another equation
the
considering the
one
relationship
of the
among the unknowns and this one.
important
So this is a
ways of
system of
countering
equations.
is
This is a system of
positive tone.
equations with k
Okay,
unknowns, and
which we
then
find
k
is
systems,
important.
k linear equations are given, and then we can
We do a
solve
little
using
more
any numerical
analysis.
analysis,
Okay,
so
now we
that
find
we can
out
apply, and
the
then all
number
the
of
unknown
likes.
k
Okay, the
values can
number
be
of
obtained,
likes
and therefore
received by
this
the
model will be
different
solved.
types
That
of
means these are
counter
the unknown
speeches.
value can be
For
obtained
the
there.
black
Okay,
community,
so it
we
is the
see
same
that
procedure. The least
online
square
and
method that we have applied to
offline
simple linear regression also can
denouncing
be
hate,
applied to the multiple linear
denouncing
regression,
hate,
and
these
then
are the
we can
two
solve the
categories
problem, and
which
then model
receive
can
the
be understood.
maximum number of
So
likes.
whether it is a
These
bivariate
counter
or
speech
multivariate,
comments receive
absolutely
the
it will not be an
maximum
issue.
number of
Only in
likes.
case of
Okay,
multivariate,
and
long
these are
calculations are
some of
involved.
the
But
examples
this
that I have
is pretty simple,
stated below
and using
for
computer
this
we can solve
community.
this problem very
Okay,
easily.
I hope.
Absolutely, this is not a big job for a programmer.
Okay,
So
so
this
this
is
is
about
actually some
regression,
white cop
and we have
who
discussed
was
about linear regression.
trying to
Now let us come to the
you know
discussion about non-linear regression model.
catch
Non-linear regression
a
model,
black person
if the linear regression, if you know,
without
it takes the form,
any evidence.
as you see, that
Okay, so
the
these are
linear
some of the
regression
cases
form, it is
that have come up
in the form. This
interestingly, and
is a degree
comment
1.
actually
So linear
counters the
regression, that means
video
all unknown variables
by
having
denouncing this
degree 1.
hateful act.
Degree means there are no square term, no cube term,
For the
or
Jewish
no
community,
or
we
x1,
see
x2 term is
that
there. But in case
affiliation-based
of
posts
a non-linear
actually
regression model,
are the
here
ones that gets
it
the
is just like
largest
if
number
it
of
is a non-linear
likes.
regression of
Okay, as
degree
I
r,
already
for
told you,
example,
that
then it will
affiliation
be
is
expressed this one. For
like you
example,
affiliate
if degree
yourself to a
2,
particular
so y equals
religious
to
community,
a
and then
plus
you
beta
try
x
to
plus
support
cx
some other
square. This
religious
kind of form.
community
And you know, this kind of
who
equation,
have
it is
been
not a straight line.
victim
This
of
kind of
hate
equation, it is a
speech.
curved line.
Okay,
So it
so
is
this
a
is one
curve.
example
It is a non-linear line
for
in a
that
high
from
dimension
that
diagram
community,
and degree of r.
and
So
affiliation
initially,
seems
the
to be
data that is
one
given
of
to
the
you, we
ways
don't know what is the degree of
which
r,
actually does
and
pretty
also we
well
don't know what is
in
the
terms of likes for
values
the
of
Jewish community.
parameters. That is
For
our
the
model
LGBT
parameters.
community,
So what is our objective? Our
that
objective is to
contradictions and
learn the
humor
degree,
are
and
the
our
most
objective is to learn
important
the model parameters. So
ways
this
of,
way we can solve the polynomial
humor or
regression model
sarcasm
or
are the
non-linear
most
regression model.
important ways
And
of
in this case, as we have
countering
considered
the
about a
hateful
single
videos.
value, then
Okay, and
y
this
is
is
a
what is
function
also
of
apparent
x, and
from
this
the
is the
average
typical
number of
function, right? Y
likes.
is a function of x, only one variable. So this is an
Now,
example of a
given all
simple
these
non-linear
important
regression model.
observations, what we try to
Simple
do is
non-linear regression
we
model.
try to
Okay,
identify
and
whether
similarly, the
a
complexity will increase
given a
if more than one
particular
dimensions are involved. That means y is a function of x1 and
post
x2,
or a
or
particular
y is a function
comment,
of x1,
whether
x2, and
it's a
x3.
counter
So this
speech or a
expression will be
non-counter
very
speech.
big and it's very
Now,
difficult.
we
Let us
use
not discuss
various
into here because
standard
it will not
machine
permit
learning
our time.
models
So this is a
to
simple
find out
non-linear regression
this
model. That means y is a
classification,
function of
and what
x,
we
but it is a
observe
non-linear
that
function.
the
It is a non-linear
XGBoost
function,
classifier
and we have to
with
learn r
sentence
and then model parameter.
embeddings and bag
So
of
basic
word
idea is
kind of
very similar
models
to the previous
gives
two
us
ideas,
pretty
actually.
good
Simple linear
results
regression,
in
but little bit in a
actually
different, little bit preprocessing
finding
regime.
out the
But idea
binary
is that
distinction
first we have
between
to
what
take
is
the
a
values
counter
of r,
speech and what
that
is
this
a
is the value of r.
non-counter
R
speech.
should
Now
be
you
greater than
might
1. So
question
start with
that
r equals
why
to
this is
2,
important. Why
then
should one
repeat
be,
the procedure,
at all
and then
interested
start with r
in
equals to 3, repeat the procedure,
identifying
start with r equals
this
to any
kind of
higher value, repeat the procedure like this one. Then for each r values,
like
we have to calculate r square. That is the
try
quantity
to
of thing.
automatically
And
classify
for that r value,
something
it
as
gives the
counter
better
speech
value.
versus
Then we can
non-counter
say that,
speech.
okay, this is
The
the
reason
model
is
with
that
degree r
it
is
is very
equal to this one.
difficult,
So this
and as you
way,
can
r will
understand, it
be
is
known.
very challenging to
Once the R
involve
is known, then we will see
human
that how
beings
the beta,
to
beta 0, beta 1, this is the
write
model
counter
parameter can
speeches.
be learned.
And
For
since
the model
the
parameter, in order to
entire
learn the
social media
model
platform,
parameter, what
that
is the basic
what is
idea?
the reason for having
This
such
idea
a
of
automatic
transform this
classifier
linear
which
equation
tries
into linear
to
equation. Now
classify
I'm telling
counter
it.
speech from
So
non-counter speech?
transforming this non-linear equation
So the
into linear
primary reason
equation.
is that
Now how we can do
it's
that?
very
I'm
hard
giving
to
an
get
idea about how a
human
non-linear equation like
effort
this form
to
will be converted into
type
linear
in
equation
counter
in this
speech
form. What
for
we are
the
doing,
different
so what
hateful
actually you can do is that
content over social
whatever the
media. So this
non-linear term it
hateful
is
content
there,
can be
all
in
these
terms
non-linear
of
terms will be replaced by
images, in terms
something.
of
For x can
videos,
be
in terms
replaced by
of
x1,
text. So
replaced by
what we
x2,
want to do is
and
we want to write
replaced by xn this one. Okay. So
robots.
if
We
we
want to have
replace this
robots
one,
or
then it
automatic
become a simple
mechanisms
non-linear
to
regression model,
generate
a
counter
simple
speech. And in
multiple
order to
linear
find
regression
out
model. If you see, because it
mechanisms to
is,
generate
so
counter speech,
here
the first thing that
x
we have
is
to do
x1,
is to
x square is
classify
x2, and xn is xr.
counter speech
So
from
if
non-counter speech
n
when you
number
have
of terms
large
are there,
volumes of
so
data.
it is a
Okay, once you have a large volume of data, you
multiple linear regression with
want
n
to
unknown parameters.
actually
So this way you
use
can
this
convert this
data,
non-linear equation into a
classified
linear
data, to
equation.
generate
So
more
the
counter
task
speech.
dealing with
Okay,
the
and
polynomial
that
regression
will
model
be
or
done in
non-linear
a
regression model
completely
is to convert
unsupervised way
the
by the
non-linear into
computers
linear form.
themselves.
So
There
this
is
way
no
we shall
human
be
in the
able to
loop,
convert into
because it
linear
is
form,
very difficult
and then
also for
for
the
the
humans
unknown, for the
to
training
generate
data,
such
using the
huge volumes of counter
same
speech.
procedure as
Because
the
every
simple
social
linear
media
regression, we
platform
shall
now
be able
needs
to
a
apply, and
counter
then we
speech engine,
can
and
solve
it
this
is very
problem.
difficult to
So
involve many
non-linear is
although
important
there
for
are
the
many
multiple data
NGOs
camps
doing this,
often.
but it is beyond
this is the
human. It
idea
is going
about
beyond human effort.
not
Then
the
we also
regression
do a
analysis.
multi-level classification
Okay, we have
where
one more topics
we
to
actually
cover. It
try
will
to
take another
classify
15 minutes or so,
the
not more than 15
counter
minutes. If you
the
allow,
counter
then I
speech
can
that we
discuss.
have got
Otherwise, I can
into the
stop it
different
here.
classes.
Now it is
There
up to
also we
you.
get a
So may I
pretty
know
good
exactly whether you can proceed it
accuracy,
or we can stop it
and
here.
but,
Is the
but
auto
of course
regression
this can be
analysis?
improved, and we are presently
Okay, fine.
looking into
So
mechanisms as
let's
to how to
proceed. So
improve this
it will take not more than
methods,
15
and
minutes. It is easy
also
again
to
because we have
generate
learned all the
counter
existing
speech
ideas, so it can be
automatically
applicable to
using
here
this
also.
data that
Only
we
few more
have in
slides are
hand.
there, maybe
We
five,
will
six slides, so that
try
you
to
can cover it
classify
easily. So
counter
whatever the
versus
data that we
non-counter,
have
and then use this
considered
counter
so
speech
far,
messages to
they
generate
are
more counter speech messages
ordinary data.
using some sort of a
Ordinary
sequence to
data
sequence
because
models,
they are
like the
ordinary,
language
but there is
models that
other data is called
we
the
come
time series
across
data. So auto
from the
regression analysis is
different
applicable to time series data. Now let us first
big
learn about
companies
what
like
exactly
the
the time
GPT,
series
etc.
data
We
looks
plan
like.
to use these kind of
Now time series
models in
data
order to
are
generate counter
just like a
speech
rainfall data,
automatically,
So
so that the
you
human
can
effort can
collect
be
what is the amount of
reduced.
rainfall for a day, for
So
every days, for
I
a
stop here,
period, for
and
20 years, for
this is
50 years, this kind
like
of
a
data. So
website
this will give
where you
you
can
the
go,
data
where you
versus
can
time.
get all
So
the
that kind
data
of data is
sets
called the time series
that we
data.
have developed,
As an
all the
example, for
papers that
example,
we have
how
written
the
regarding
Indian
this
rupees
topic,
or Indian
all the
price
papers that are
are
being
fluctuated,
written
right, with
worldwide,
different
all the
years.
developments that
So
take
we have
place
collected very
across
long
the world
data
in
for the
this
different
particular
year, and
area.
then data for a
All this
year may be
information
divided
you can
into
get
a
on
month
this
data
website. So we
or daily
continuously keep
data
on
or
updating
week
this
data,
website.
whatever it
If
is.
you are
Yeah.
interested, you can.
So for
So
a year,
if you are
we
interested
have taken,
in
for
specific
example,
forms
weekly
of
data.
information,
Every
you can
week, what
write
is the
that to us.
inflation,
We will be happy
right?
to
And
answer
this
your
way, it
queries.
will give a
Thank you
time
very
series
much.
data for
I'll
every
stop here
week,
and take
and for
questions.
a say maybe say last 10 years
There
or last
are
15 years
two
data we can
questions.
collect. And this data will
What
look
about
like this. So
0.25
this
to
data will look like
0.75?
this. Is
How are
a
we able to
every
track
data
personal
has its
messages?
time point, and then what is
And
the
the
value
second
point.
question
So
is,
this is a
what about
typically called the
privacy?
time series data. So data vary with time.
Okay, so that does not
Now, given
actually
this is data,
disturb our
it
result.
is one
So,
model
but
to
then
be
we
developed.
wanted
The
to
model
have
will
this
tell you
high
if the year,
hard
for example,
threshold,
say
so that hard
2020,
threshold
what
both
will be
sides,
the
so that
inflation.
we are
Okay,
very
so
much
this means
sure
take
that
this data
whatever
into
we are
your
choosing or whoever we
confidence
are
and
choosing
then predict
are
it. It is just like
largely
given a set of
either
data as a
strongly
training data.
hateful
So
or
you can
strongly
consider this is a training data
non-hateful.
that is given you. This is a training data,
Okay.
and we have to predict some
What is the
unknown data
second
for some unknown
question?
year or for some
How are we
unknown
able to
month.
track
What
the
is the
personal
inflation?
messages?
So this is
I'm
the
not sure what
prediction, right? And this
if
kind of
I get
prediction is applicable
the
either in a stock market
question correctly. Can
prediction
the audience
or
come in
prediction
mic and
about the
explain?
dollar change, the
What do you mean
conversion
by
values
personal
between dollar
messages?
and Indian rupees, or these kind of things are there. Even the
So good
prediction,
afternoon,
the way the
Mukesh.
Yeah,
forecasting also we
yeah.
can apply it.
So,
So time series
see,
data
Go
has
ahead.
huge application in many
as I
regular
said,
application
is it
in
only
many
about the
decision
post
making in
which
many
is
business
been posted
processes.
publicly,
So this is about the
or
time
do we
series data,
also
and
track
whenever we have
the
to find a
hateful
prediction, as
messages
we have
like
already seen the
we sent
prediction,
through messengers?
prediction of y for a given
No,
value of
no,
x,
no,
or
no. These
prediction
are
of
only
y for
public
a
posts
given
that
values of
appear on the
x1,
walls.
x2, xk. This kind
So
of
you
right prediction.
do not
So
have
here also
access to the
prediction, but we take
private
prediction for
messages.
a given
So
time,
therefore, the
given the
privacy issue
previous
is
data
also
it is
resolved. So it's
available.
only the
This kind of regression
public messages
analysis
that come
called
on the
the auto
walls.
regression analysis. Okay, so to
Okay.
make it
What about,
differentiate with
see,
the
like
previous
we
regression,
have
it is called the auto
options
regression analysis.
to of previous years,
The
like
auto regression
for public,
analysis has the
for
different
friends,
application, as I
for
already
only
told
me,
you, to
for
develop the
acquaintances.
focused model,
So,
to
what
estimate
about
if will
that
happen, then what will
privacy
happen, which is
levels?
required in business processing, and then some time
Yeah,
dependent
so
analysis.
basically
How
whatever
the how a
you are
particular value is
probably
changing with
being
time. This kind
guided by
of many
Facebook.
other business
In Gab,
application it is there.
such privacy
So, for
levels do not
example, can
exist.
we predict
Okay, so
the
we were mainly working on
2017
Gab. So
dollars
on
per
Gab, this
pound,
kind of
given
privacy
this
levels do not
dollars per pound
exist.
of the
But
previous
even
data
if
or
they
history data?
exist, whatever
So
is
this is
visible
for
to the world,
forecasting, and these are
that
the
is what we will be
many
considering.
equations are there.
Okay,
Now let's
so
see
we will
how
get
to
into
Nowadays
predict
those
there
that,
are
how the
definitions.
options.
regression model, that is the
Whatever
model
is
can be
visible to the
predicted,
whole
so that
world.
we can use
Actually,
this
if you go
previous
to
data
Gab,
to
if you
predict the
sign into Gab,
future
people
data.
hardly
So
care
to do these
because it's a
things, it
free
required
platform,
to
and
calculate
you can spit
one
venom as much as possible.
value. This is called
nobody is going to stop you
autocorrelation
there.
coefficient.
So therefore,
Or
there is
more
no
precisely,
reason
it is
to
called the
hide
death
yourself.
autocorrelation
Why
coefficient.
people hide in
It
the
is
other
usually denoted
platforms
by the
is
symbol
because
rho g. This is
of
the
the
formula for
backlash
autocorrelation
that they
analysis
might have
formula.
to
And it basically find
encounter.
covariance.
So
Covariance
here
of
there is
YT
no
by YT minus J. The
problem of
covariance, the
backlash.
simple
Nobody is going to
xi
tell them anything.
minus x
It's
bar into
completely
yi minus y
unmoderated,
bar, this
and
kind of
therefore
things
there
are
is
there.
no
If you want
fear,
to covariance
and
between
that's
x
why
and
they
y. So for
hardly
all
care
values
to
of x
post
and for
any
all
message
values of y, is the covariance needs to be there. And then it is the square
privately.
root of standard deviation of
I mean,
yt
especially
and
heads,
yt. Now
head
you know
messages.
that yt for a tth
Thank you very
year.
much, sir. Looking
And
forward to your
what is the t
contribution.
minus j?
Yeah.
It is just t minus jth year. So 2 years. For example, t if it is 2010, and then it is if j is 2000, t minus j is 2005. So we have to find the covariance of data between 2010 and 2005. And the data actually in the 2010 data and 2005 data, again you should assume that this data is given for 12 months data or 54 weeks data or 365 days data. So depending on how many range of values are there, either 365 or 54 or 12, and depends on this one. So these are the set of values, right? Okay, so these are attribute, we can say these are another attribute, and between the two attributes you have to find the covariance. And this is again the standard deviation for the TH attributes, and this is a standard deviation for the this one, so root over this one. So this is the idea about auto correlation coefficient calculation. This required, okay, this required for our calculation, it is there. Now the model which will look like this one, it is called the pH auto regression model. That means depending on, say suppose you have given 2015 data and then we want to calculate 2020 data. So in that case you require p equals to 5. So fifth auto regression coefficient. If you want to predict for the just immediate next year data, then is a one row, a single row, one p equals to 1. So it is the first auto regression model. Similarly, second means given the current year, then next 2 years data. So second order auto regression model in this way. Now let us consider in general, this is the pth auto regression model. That means we have to predict that predict the data after the pth order, after the pth period, and then it is like this one. So the equation it is look like this. So we can predict the pth model given that the p. So that means for y equals to 1 to I equals to 1 to p, and beta I into y t minus, so it is t minus 1 and then t minus 2 up to t minus p. So these are the values it is required. So this is the model. That means tth year data can be predicted, or tth data can be predicted taking the confidence of t minus 1, t minus 2, t minus 3 dot up to t minus pth data. So definitely we have to calculate the different model parameter. That means yt can be expressed as a beta 0 plus I equals to 1 to p beta I yt minus I. So this is the model. So this is the model. It is very similar to the model. You can see the linear regression. We can consider it is there. Linear regression. It is actually linear regression look like, because the degree is always 1 here. So in this expression, therefore, given a p, that means which prediction you want, and then we have to calculate these are model parameters. So beta 0, beta 1, beta p, they are essentially the auto regression coefficient. And the auto regression coefficient, this is the formula that I told you. Okay, so we have to find the formula for this one. Now let's see how we can calculate this formula actually. So we have to calculate, this is the unknown parameter for beta 1 to beta p, and there is a very simple, the detailed calculation is beyond the discussion. This method is based on least square method. The least square method follows one equation to be expressed. It is just like a nonlinear, simple multiple linear regression. You can say the system of equations, a system of k number of equations, and solving this k number of equation you can express in terms of matrix form. A x equals to b. So here it is like, this is the coefficient matrix A, and this is the unknown. It is the x matrix, we can say is equals to b. This is the constant matrix. So this is the system of equations, right? Now in this system of equation, let's see what is the coefficient matrix, and this is the unknown that we have to calculate. Here unknown is beta 0 to beta 1 to beta 1, beta 2 dot beta p. So this is the unknown. Okay. And usually in this equation, beta 0 is the bias. Bias is usually taken as 0. So that is why here P unknown parameters to be calculated. So if we consider this is 0, usually it is taken as 0 in auto-regression analysis. Otherwise, by empirical method, the beta 0 can be calculated. So we can ignore the calculation of beta 0. So we have to calculate beta 1 to beta p. So this is the unknown model parameter to be calculated. So this is the unknown parameters. Okay. And then what is the coefficient matrix? Coefficient matrix, it is a very systematic one. After a long calculation, we can got this. I just wanted to mention what exactly this one. It is a row 1. I could write R1 actually, but please you read at row 1. So 1, it is a constant. All the diagonal entries will be 1. And then it is row 1, row 2, up to row p minus 1. So this way, we have to calculate the autocorrelation coefficient up to p minus 1 autocorrelation coefficient, starting from first autocorrelation. First autocorrelation means that this year, the next year. Second means this year and previous 2 years. Row 3 means this year and next 3 years. So this way, all the autocorrelation coefficient can be calculated. Row 1, row 2, row 3, up to row p minus 1. And we can arrange in a little bit systematic cyclic manner like this one. So if R1 shifted towards right by 1, this one, then this one, and this also, it is cyclic shifting rate. So this way, if we know all the autocorrelation coefficient starting from 1, so row 1, row 2, row 3, up to row p minus 1, we shall be able to form this kind of coefficient matrix. And this is the unknown matrix we have to, and this is again coefficient matrix R1 to Rp. So this will give you a system of equations, and this system of equations is a linear system of equation, can be solved using any numerical method. This means that if we can solve this system of equations, we shall be able to calculate beta 1, beta 2, beta 3, and beta p. And by this process, we shall be able to calculate the model parameter. And this means that model will be solved. And then beta 0, beta 1 will be unknown, it is solved. So model will be learned. So this way, this is a machine learning approach that the model can be learned, and therefore we can predict the time series data that is there. So this is about my presentation for today. So we have covered 3 things in general. So starting of the machine learning approach, and that is by means of statistical process actually. So statistical method that we have discussed. We discussed about 3 things. One is that firstly it is the relation analysis. Under the relationship, correlation analysis, and then regression analysis, then auto-regression analysis. Under the regression analysis, we have learned about Karl Pearson, and then Spearman correlation, and then chi-square analysis. Under the regression analysis, we have learned about linear regression, non-linear. Under linear, simple linear and multiple linear, and then simple non-linear regression, that is also called polynomial regression, and finally auto-regression. So this is my submission for today. And I can take a few questions if you have. It is better to clear if you have any doubt. So if you have any questions, please you can write. If there is any chat, also you can put your question to the chat box. Otherwise, you can ask question directly to me so that I can take few questions and then you can have doubt. Yeah, please. Okay, fine. So Rahul, your question is, could you please show the question here? Which book that I am following? So there is many books are there. One book is very good. It is a statistical learning method. Okay, it is statistical learning method by Walpole. I could give the reference of this book in this slide. I forgot to include the reference of books. So these books are there. And so this is the books that you can follow, but this book is exhaustive and then too much critical. I have simplified in terms of equations and expression and then organization also. So this is the book Walpole, W-A-L-P-O-L-E. Walpole book is the book that you can refer to, and it is a good book for learning all those concepts. And there is few more books also there. I'm telling you, one is called the Timberseni, and this is called ESL, Essential Statistical Learning, and another is by the same author, Timberseni, Timbersini, Timbersini. You can just search the things, and then it is the popular book is Essential Statistical Learning. Also, you can search by the name, or Introduction to SL, Statistical Learning. So 2 books are there by the same authors. This is a very good book. Many people like it. And it is the essential statistical learning is for the beginners, and introduction to statistical learning for the advanced reader. So these are the 3 books that you can easily follow for better learning, statistical learning.
Thank you very much, sir.
Okay,
And,
Yomi, sir.